It's been a long journey of you working on this project. And this presentation here is the culmination of months of work from lots of people. Okay, we always talk about the 3 I's of ISU. We know I is our favorite letter here. There's also 2 other letters that are important at ISU, T and P, team project, all right? And it really represents well the 3 I's of ISU. I don't know if you know, but our team project subjects and questions that are asked come from our international community of alumni and stakeholders in ISU. We make a call to them as the faculty, and from that we take that to decide what projects are going to be worked on each year. And so it's meant to have an international impact, so we asked internationally. And then when you think about the work that you've done, amazing work you've all done with representing all your different countries, there's a lot of intercultural exchange that happens there. For some people, it might be the first time they meet someone from Zimbabwe or maybe meet someone from Portugal. Yeah? Now that person is your frame of reference moving forward as you go work on the global platform that is the space ecosystem. And so you learned a lot from each other through that intercultural experience, right? Now, interdisciplinarity. That's something that is really amazing about these projects because you take teams of engineers, right? The engineers the obvious, the scientists the obvious, but you got also the less obvious, like the lawyers, the doctors, the communication specialist, the graphic designer, the artist. You put them all together into a project, and you really get some very, very impactful work that comes out of it. And so what's this year? What is the 4th I that we added to ISU? Innovation, yes. So, and that's where our TP has been very innovative this year. It's actually a very different TP than usual. Here in this TP, we've asked the students to actually produce something. Not just make the report, but go a little bit further than that and create a software or a prototype or a podcast or all these different ways to engage with the community at large, besides, of course, our amazing reports that are going to go into our library. Remember, our TPs is a tradition here that's been happening with MSS and SSPs going back for years. You all went to the library and saw where you can check them out and read what other people have done in the past. We also have our digital library where people read these. They have impact beyond the classroom. It's not just a learning experience. And so the innovation this year is that we didn't just have, of course, our reports. We also had these amazing extra products that come out of this that you're going to see in the TP presentation today. So it's a little bit different than usual, but this MSS class is a little bit different than usual. So I feel that you guys are extremely enthusiastic, resilient, innovative, and hardworking. And I haven't had much experience with TPs, but whenever I see what you guys have brought to the table and I compare to all the students I've taught in the past, you've all brought A game to this. So I think that we're all going to be impressed for my last I, okay? So without further ado, I want to introduce Team Umbrella. They have a very interesting project, and I think it's going to be impactful and interesting. At the 1 hour, I'm going to be cutting you off to ask you some questions. We'll be taking questions first from our faculty who are joining us online, and then we'll move to our faculty that are here in the room, okay? Without any further ado, Team Umbrella.
Good afternoon, ladies and gentlemen. Today, TP Umbrella is proud to present its final presentation regarding the proposal of the next generation of Martian rovers and drones in space exploration missions. To help you understand where we are in this presentation, here's a brief overview of the topics that we will cover this afternoon. We have the intro, the budget eval, our mission, human systems integration, technical systems, policy considerations, public outreach, and finally, our future missions and conclusions. Our project brief was to pioneer a concept of integrated rover and drone operations working in unison for a mapping mission of the Red Planet. The twist was a 95% reduction in the cost from the Mars 2020 $2.5 billion, which resulted in a hard cap of $125 million for our project. We utilized the ISU 4 I's, intercultural, international, interdisciplinary, and innovation in order to accomplish this task. Let's examine how our team operated within those 4 I's. We have a diverse mix of backgrounds, sometimes multiple backgrounds, and sorted ourselves into teams. You can see the interactions between each team as well as their size in this web to help illustrate the interdisciplinary nature of this project. To help you understand what topics and which teams worked on what, we will highlight this in the top right of our presentation. So let's move on to our year. We started with the literature review in this fall to examine the scope of Martian exploration. At first, we were unsure of even pursuing a scientific mission, as we were examining a pure technological demonstration because of the budget. However, our research led us into systems used now and in the past, technical developments, different evaluation costs to reaching Mars, space exploration policies, and the usage of AI in our current exploration tasks, and how humans integrate into that system. That was a very wide web to cover, and so we had to trim out a lot of fat from our literature review to now in order to help illustrate the changes that took place over that time period. So what were the constraints that we faced within our project? Our budget was $125 million and was a major constraint to our mission, and it essentially boils down to how do we make space cheaper and more accessible for future mission operations? Next was our trade-off analysis. We needed to examine tested versus innovative technologies, technical requirements, power, level of autonomy, and mission scope, instrument selection, and design choices. This made us prioritize what we needed to do in order to make the rover execute its specific Martian mission, subsurface mission task. And finally, the mission parameters. This included launch windows, Martian weather, and safe landing requirements such as uneven ground. Now let's examine the budget through our motto, efficiency through austerity. We prioritized 3 points: heritage resilience, single point failures, and lean operations. By not having to develop a dedicated design process and re-examining older designs that have worked, we were able to extrapolate a potential 75% reduction in cost from the initial mission. We accepted single point failures because because this is a launch point for future missions, and redundancies increase costs in a testing environment. And finally, we prioritized leaner operations, targeting people with multiple different backgrounds and expertise in order so they can overlap in their tasks. Let's start at examining what we concluded in the literature review. Here we can see that according to sources from the Government Accountability Office on NASA reports and organizations such as the Planetary Society, and we found those sources to be the most insightful when it came to Martian exploration costs. Other governments may have other exploration missions, but the exact breakdown of those costs are not very transparent and kept close to the chest. Therefore, examining the past NASA Mars 2020 Perseverance and Curiosity missions helped our team visualize these costs associated with each bracket depicted here. As you can see, the development bracket takes up 80% of the costs, and launch and operations take up a much smaller piece of the pie. However, our issue with this is that development is this huge, massive chunk, but it's not very transparent either. It's the largest driver of cost, so that's what our team sought to reduce first. We ended up dividing development into 3 different categories, as illustrated here: components, manufacturing, and testing and verification, and assigned a percent value to each cost bracket. We derived launch costs from the recent NASA DART mission, which launched on a SpaceX Falcon 9 and cost about $69 million. But if that is unavailable, we have also modeled higher costs, which eat into our exploration budget as well. However, this is informative. However, we felt that there were specific details missing, which led us to our final conclusion, which is the bottom-up approach. The cost of each component is added together or estimated based off of our research. The capital is allocated as follows. Launch is number 1, components number 2, personnel number 3, and manufacturing number 4. This ensures that easily accountable costs are accounted for, and the more difficult costs are left flexible to address later. For example, if we are unable to build fully decked out cleanroom facilities, we suggested that we could purchase portable cleanrooms that cost significantly less, and then cook our rover and drone parts in heat temperatures for longer in order to make sure the spores are killed to stay compliant with certain planetary policies such as COSPAR. Here is an example of the sum of the parts for the EDL system. We broke down what was needed in order to implement a Sojourner-type landing system. We estimated what the mass would be, and then finally, we allocated those costs based off the cost of the component, the mass that we estimated, along with the redundancies. In case someone drops a booster and it's broken on the factory floor, we're able to still build the EDL system and execute the mission. This nets out to a budget breakdown that looks somewhat like this. It's dominated by launch costs. However, we felt that it was a transparent insight into our mission and how it is executed. So finally, let's take a look at our project timeline. Like with most business models, we divide the mission into several phases. At the beginning, we have conception and planning on how we will execute this project, followed by manufacturing and testing, which we will estimate take around 1.5 to 2 years. Following that is a transit to Mars, which will take 6 months and will require a skeleton crew just monitoring where the spacecraft is and its health. So that will lower costs. Finally, in the EDL and mission operations, the full team will come back for 1 week, ensuring our combination rover and drone duo are able to execute their mission. Now here is Luis to introduce the subsurface mapping mission.
Thank you very much. Hello everyone. I'm very happy to present the scientific aspect of our TPE project. I want to start by showing you everything related to this endeavor, starting with the overview, the why is it innovative, its main objectives, all its phases, and success criteria. Later, I want to show you a simulation of how science mission would work once our instruments reach the surface of Mars. And I also want to show you the strategic plan that we built to keep our assets long after our mission is concluded. So, as you all know, the Martian surface is quite well studied, quite well mapped, because there's not a lot of geological activity and the atmosphere is quite weak. But there's still some vibrations under the surface. They are called the Mars quakes. Despite being, this was actually found by the InSight lander, NASA's mission of 2018. That was the first mission that actually detected liquid core, and the thickness of the mantle and crust. So far, 2 of the rovers have probed into the subsurface, starting with Perseverance, the Zhurong rover from China, and 2 orbiters, the Marsis and Sharad orbiters. They were using ground penetration radar to pierce through the surface and detect all its features. So why am I this technology has actually a little bit of a hindrance because the deeper it reaches, the less accurate it can become. So why am I telling you this? Because this is where the innovation aspect of our mission comes in. From the start, we all wanted to do something new, something relevant that could improve the human knowledge. So the technology used today to understand the subsurface was developed by the oil and gas industry. It's called the active seismic sensing. Its purpose is to find what is hidden under our feet. What has not been tested, which has not been tested anywhere else apart from Earth and Moon, we as a team endeavored to bring it to Mars. Why is it important for us to bring this technology there? Care to guess what is the most important resource that we want to explore there? It's ice, water. But we don't want to stop there. We actually want to further explore the subsurface to look for the potential future habitats of humans. Care to guess what it is? It's lava tubes. With our mission, humans will have for the first time close-up images of these mysterious caves. This will all be possible through our Hades and Hermes instruments. Hades, the Greek god of the underworld. It is the rover that we built exactly to be the first one to do active seismic sensing on Mars, to help scientists understand the physical properties of the subsurface and potentially map the locations of water, their volume, and map the networks of lava tubes. Hermes, the messenger of the gods. This is the drone that we built exactly to survey the landing and exploration areas. The most importantly, to photograph lava tubes up close. So, with our ambition set, we agreed on 2 mission objectives. Our primary objective was to design a mission concept at 95% of heritage missions, such as Perseverance and Ingenuity. And to do that, we had to learn how to integrate AI models for robotic autonomy decision-making. This would make complex Mars missions more accessible to smaller and privately funded space actors. Our secondary mission is to have a proof of concept of a mobile active seismic sensing application for the Martian subsurface analysis and develop a realistic swarm-type architecture of these instruments for mid to long future missions. So, we had to set the success criteria, starting with completing the Mars transit, the EDL, entry, descent, landing into the exploration sites, the deployment of the rover and drone, the functionality of these instruments for a period of 7 sols, the acquisition of geoscientific seismic data, and, most ambitiously, the aerial imaging of lava tube skylights. Now, question is, where are we landing and why there? For the why question, there are a lot of subsurface conditions for the EDL's safety. We need a fairly flat area, free from objects. Another criteria is the surface temperature and its weather conditions. So our team had actually to look for these weather predictions and models in different latitudes of the Mars surface and estimate the landing windows to ensure that the mission would not suffer unexpected consequences. We could not establish our landing sites too much up north or too further down south, since the temperatures in these regions might affect and compromise the instruments. We use NASA's JPL Horizon system, and we assume a landing on August 2030 or February 2031, which means early spring or early summer, respectively. For the where question, our team had to scour the entire surface of Mars, and as you can see, the yellow dots are representation of the positions of the lava tube skylights. So we need to be proximate to our scientific objective. So, with all these criteria met, we chose the Elysium Planitia, southeast of Elysium Mons, and this is the landing ellipse, and this tiny dot right here is our preferred and optimal landing site. This is where we are expecting to have the perfect landing site for us, and the exploration site. Now, please imagine with me what it would be like if the rover and drone were placed now in the surface and we can see them. So, starting with the rover. The rover, first, once arrived, he has to perform what is called the wheel trenching. It's basically removing the loose regolith from the surface, from the immediate surface, for a higher contact of our instruments with the bedrock. This instrument is called a PASS unit. The PASS unit stands for Portable Active Seismic Source. It will be the instrument responsible to create the seismic waves that it will eventually be captured by the geophones that are placed on each one of the wheels of our rover. This was an ingenious way that our team built our system to capture this active seismic sensing without the need for extra instruments. And to maximize the area and the data that we can collect, we had to establish a pattern, an outward square-like pattern that we can, in each corner, the rover would stop, collect the data, and transmit it back to Earth. And to produce what? This is the expected result that we would get from a rover and this type of system. This is what we would expect to see if we would encounter ice, for example. This is what we would expect to see if we would encounter lava tubes. This is how we would model them. This is how we would create the 3D aspects of it. So now, for the drone, Hermes. Hermes will be essential to do aerial surveys. It will be in constant contact with our rover, and both of them will be in communication so that the drone will do a scour of the exploration area and send that information back to the rover so there's no hazards. It will help path planning. So this is the type of results that we would expect to get from also the cameras that are embedded in the drone, some digital terrain models. If we could do a meshwork of high resolution imagery from them, this would be the ultimate result. Now, most ambitiously, we want to put our drone inside one of these lava tubes. This is how we would imagine how the drone would go inside and start mapping these structures. And this is the type of data that we would be able to model for future human missions on Mars. This will let us know if it's habitable and reachable for the humans to build something there. So, our entire budget was allotted for the total of those 7 Sol missions, 7 Sol period. From then on, we go over budget. But we thought about this, and we came up with a business plan to maintain these assets still functioning on Mars. We will provide third-party entities time slots. Since Hades is equipped with an AI-powered multispectral camera, these entities have a valuable asset to use for their research purposes. The same with Hermes. It will still be operational by continuing doing aerial surveys and path planning assistance. This is also a valuable asset present on Mars for these third-party entities. By selling these time slots to entities, we are able to extend the lifespan and usage of our instruments long after our mission is complete. So now please welcome my colleague Sarah to explain the human aspect of the mission. Thank you.
Thank you, Luis. Hello all. All right, so after covering the science aspect of this mission, I'm going to be covering the human aspect of it, since we're going to always have humans involved no matter what. So as you might all know, Mars missions experience significant communication delays of up to 20 minutes, and which actually makes real-time human intervention really impractical. So consequently, in these situations, our Mars mission, Umbrella Mars mission, needs to leverage autonomous systems that are capable of making and executing decisions on their own. However, it's worth noting here that autonomous systems add an extra layer of operational complexity, and an effective collaboration between human operators and autonomous systems is really necessary for mission success. So as part of this project, we propose a human-in-the-loop study to actually examine the interaction between human operators and autonomous systems to improve the probability of mission success. So the objectives of this study would be to inform decisions on staffing decisions and to also determine the best autonomy level and task type configurations that improve performance, efficiency, and safety. The goal would also be to examine or evaluate how different autonomy levels affect human performance in addition to key human factors variables like cognitive workload, situational awareness, and trust in autonomy. Okay, so these outcomes, which I just covered, will be measured using different assessment methods and tools with strong psychometric properties. So for cognitive workload, it's going to be measured using the NASA Task Load Index, which is a multi-dimensional tool that contains 6 workload-related domains, including mental demand, physical demand, temporal demand, effort, frustration, and performance. Situation awareness, on the other hand, will be measured using the situational awareness assessment, global assessment technique, which allows for the assessment of the 3 levels of situational awareness, which are perception, comprehension, and projection. As far as trust in autonomy, it's going to be measured using the human-robot interaction scale. So this assessment tool actually assesses the operator's trust and perceptions of autonomous systems. And then finally, operational performance will be measured through 2 key criteria, which are response time and decision accuracy. Okay, now moving on to the experimental procedure. So we decided to use a sample size of 20 participants in this study who will satisfy a number of predetermined or pre-selected inclusion and exclusion criteria. So for the eligible participants, they will first complete baseline measures of cognitive workload as well as trust in autonomy. And then they will have to go through a training session to get familiar with the user interface and also the situation awareness assessment technique. And then they will be randomly assigned to either the partial autonomy condition or the full autonomy condition. And within each experimental condition, they will be completing tasks under both routine operational conditions and also off-nominal conditions. And what I mean here by off-nominal conditions, or at least what we chose as an off-nominal condition, are dust storms, which are really frequent on Mars. So while completing the study tasks, performance metrics will be collected, but also situation awareness will be measured by freezing the user interface at random intervals and also querying participants on a number of key situational awareness aspects. Examples of that would be like questions, for instance, about the rover's current position, but also navigation strategy, and also potential actions based on environmental conditions. And then finally, cognitive load and trust in autonomy will also be measured again post-task. So this is actually the user interface that will be used in the study. This is Umbrella's mission user interface, to which we added a number of features that are important for our proposed study here. Examples of these features include recording response time and decision accuracy, but also implementing the different experimental scenarios that will be used in the study. The user interface contains also a number of different panels that display different types of information from rover health and power to mission information. And then this is actually one additional feature that was added specifically to the partial autonomy condition, which would allow the human operator to either trust the decision of the rover or override it. Now moving on to selection, and I would like to bring your attention to one point here. So the outcomes of the study that I just described here, the human in the loop study, will not only inform us on the best or optimal autonomy level and task type configuration, but it will also provide us with a better idea on how many human operators we would need for the mission, like the optimal number. So these operators will be selected based on a number of key criteria. They will be selected based on cognitive abilities, like response time and problem sensitivity, but also teamwork and communication skills, which are really important for Mars missions, since they highly depend on teamwork, effective teamwork, clear communication, and strong interpersonal skills. Other skills, key skills here for human operators on Mars missions include emotional resilience, important to maintain focus and manage stress, and also visual acuity, which is important for an accurate interpretation of imagery and sensor data. So all these selection criteria will be assessed, or we're going to be using different assessment methods for selection, including psychometric testing, operational simulations, as well as behavioral interviews. So once selection is finalized, then the human operators will have to go through a predetermined number of training programs. These training programs include a training on mental acuity, which will focus on decision-making under pressure, multitasking, as well as problem solving. Then we have an important training, which is on teamwork and communication. This is really important to improve collaboration and communication between team members. And also emotion regulation training, which will focus on, adaptability and being able to basically manage stress and be able to perform well under high pressure situations. And finally, robotic operation training, which will cover navigation, emergency protocols, as well as managing system failure. And now I'm going to pass it on to my colleague Asta to cover the engineering aspect of the Umbrella mission.
Thank you, Sarah. So, now let us delve into the technical details of our project Umbrella. So, our engineering section is basically divided into three subsections: EDL, rover, that is our Hades, and the drone, that is Hermes. But before that, how and what time will we launch? Which orbit will we launch? So for that, we perform some STK simulations in which the Cronus will take our lander to Mars from the orbit of Earth. And this is what we get through STK simulation. We also get to know the eclipse time, the solar time, and power calculation based on this STK simulations. Now, once you reach the orbit of Mars, what's the next step? You need to land on the surface of Mars. And for that, you need EDL, that is entry, descent, and landing. This is the most risk-oriented part of our TP umbrella. And for that, we have specially 3D printed the whole structure to give you a clear idea about it. The below part is the heat shield. The middle part is the aeroshell, which we used for a hypersonic entry in the surface of Mars. And the upper part carries some battery panels and parachute for supersonic landing. We have also rocket assisted landing, which reduces the vertical velocity while landing on the surface of Mars. And finally, the end step, we will have an airbag system which provides a perfect cushioned landing. Next, let's move on and have a look at our rover. So what image you are seeing here is basically a system architecture and power architecture of our Hades, which shows how each of the sensors and systems are integrated with different communication interfaces, that is I2C, SPI, or UART. And in the center, you are seeing the very cute CAD model, which shows exactly where solar panels are placed, where our wheels are, how our seismic sensors are placed and fitted into those wheels, as well as the pass vibrators. And the whole system is covered with a warm electronic box. But how this system works, how we divide this system into various subsystems. So now let's have a look at the various subsystems. So our first subsystem is mobility, which is basically a 6-wheel rocker bogie structure. This is just a prototype wherein we have a main rocker arm followed by a suspension bogie, which carries middle and rear wheels. Next, what we have is wheels and traction. So our wheels are not just for rolling on the surface of Mars, but they are part of scientific architecture too. Our wheels have outer traction rim as well as a place to fit the seismic sensor inside. So that's how our wheels work. Rover takes a pose, the pass vibrator gives the vibration, and these geophones track the seismic data. Our third subsystem is the structure subsystem, which is basically the mechanical backbone that provides structure to our rover. Next subsystem is thermal subsystem. We all know that environment in Mars are very harsh and very cold, so especially at night. So yeah, we need thermal control, and which is necessary. And for that, we have used a warm electronic box whose outer surface is gold chromated to reduce the solar losses as well as heat losses, and which keeps our electronics safe. Next on, we have power subsystem. Here you can see this is our prototype, which just consists of the avionics of our rover. And yeah, power subsystem is from generation of power from the solar panels to store those power into form of DC into those batteries, and from those batteries, this power is distributed through a power distribution system, which is known as EPS management, to all the subsystems. Next is command and data handling, which is basically an onboard computer and control layers, which manages commands, stores data, processes sensor input, and handle fault responses. Our next subsystem is autonomy and navigation. Communication is always delayed on Mars, so our rover and drone cannot always wait for commands. If that happens, it will just keep waiting. So we have given them the power of autonomy by specially fitting in GPUs for autonomous AI path planning. Next subsystem is the communication subsystem, which is basically a 3-tier communication system wherein we are using 2 different types of frequency bands. For deep space communication, we will be using X-band, which will communicate from orbiter to ground station on the Earth. And for local or relay communication, we are using UHF, that is ultra high frequency, which will help for communication between our rover and drone as well as our rover to the orbiter. Next subsystem is the science payload, which is basically the main mission that my colleague Luis just mentioned. Another subsystem is payload deployment, that is basically executing and deploying the rover and drone duo on the Mars surface. And final subsystem, that is fault detection, isolation, and recovery. So there are various phenomena like overcurrent, low voltage, overheating, or there is some fault in our sensors. What do we do in these situations? At this point, our system just needs to rest. So whenever we detect these anomalies, we command our system and put it into the isolation mode. And that's when our system rests and recovers. So this was an overview about our drone subsystems. Now, I would like to pass on to my colleague Rishali to give you a brief idea about our drone, that is Hermes.
Thank you, Asta, for the very warm introduction. I would be introducing our drone system, Hermes. So Hermes is our aerial scout, which acts like our eye in the sky. Hermes is designed to observe terrains where the rover cannot reach. But making a robotic system fly on Mars, which has 1% of the Earth's atmosphere, is not an easy engineering feat to achieve. So I would like to delve into the subsystems of Hermes, starting off with structure. Hermes stands 49 centimeters tall and 1.8 kilograms of lightweight carbon fiber reinforced polymer. The sequence of the structure is a solar panel, upper and lower rotors, and the landing gear mounting plate suspended by a warm electronics box, and the legs that are made up of carbon fiber epoxy tubes to keep our entire drone as lightweight as possible. Our EPS system, our electrical power subsystem of Hermes, is designed efficiently, keeping safety as our utmost priority. So the power generation starts from the solar panel, moves into the lithium-ion battery, which stores and distributes power accordingly to different systems based on their requirement in different lines, so as to not overheat or damage any of our instruments. As you can see, the lines move to actuators, rotors, GPU, and payload with different voltages. Communications. As my colleague Asta mentioned, Hermes directly coordinates only with Hades over a UHF proximity link. This is implementing and proving our concept of a rover-drone dual system, which is a precursor to our swarm architecture. The thermal subsystem, the warm electronics box, houses all of our electronics and avionics systems. This box is designed in such a way so you can control and regulate the temperatures inside this box, especially during Martian brutal winters, where the temperatures can drop to minus 70 degrees Celsius. The next is our propulsion system. This is the system that allows us to fly and have eyes in the sky. It comprises of 2 rotor systems supported by 2 long 1.21 meter blades. These rotor systems spin at a rate of 2,800 RPM. We need such high rates so that we can overcome the thin Martian atmosphere and generate lift. Our onboard computer system, basically the brains of our entire mission. So we have specifically chosen NVIDIA Jetson Orion model as our flight computer because it has an advantage of an integrated GPU. So the GPU is what gives us the AI stack advantage and computing power. This directly flows into route planning and hazard detection algorithms. As you can see, our flight computer and GPU communicate with each other with various parameters and directly send the AI output to our execution system. Last but not the least, I would like to explain about our payload system. After rigorous trade-offs of multiple instruments, our team has locked in on XI-spec multispectral camera. The main objective of the camera is to do terrain analysis from an aerial perspective. But as an added advantage, it gives high-resolution images that will help us build digital terrain models. Why? As you can see, we would like to have an intelligent decision for future exploration missions. As you can see in the image, the drone scouts the area and develops a digital 3D terrain model that will help us understand the entire terrain of the Mars. I would like to show the demonstration of our prototype that we have made for this project. Thank you, Asa. I would like to move into the next part, that is the decision model for both Hermes and Hades. Every decision that either of our systems make goes through a 5-layer decision model. As you can see to the far right, are raw parameters of our sensors, of our science models, as spectral details, etc., that gets classified into 3 more layers, such as science, traversability, as well as resource management, because all of our sensors have to be optimally used due to our power constraints. It then moves into a decision manager that flows through multiple machine learning algorithms and neural networks with keeping in mind certain specific parameters, that is the target, the mode, and the feature that we would want to observe. This decision is made and then sent to our execution model, which respectively executes each and every command. I would like to give you an example of what I have just explained. That is, as you can see the dashboard, it's a custom-made mineral spectral analyzer which is created based on the largest mineral database. As you can see, USGS Spectral Library. This dashboard is developed with AI intelligence to accurately analyze the mineral reflectance off of Martian terrain. As you can see, we have already identified 105 minerals that we found on Mars that matched with the Earth's terrain. I would like to present to you our mission dashboard. This mission dashboard acts as our one-stop shop that integrates all of the data from all of our sensors, instruments, and systems for a seamless user experience. As you can see on the top, Hades, Hermes, and payload data. All of this is accessible on a single screen. As you can see, the thermal control, navigation and guidance, which has the coordinates, the solar arrays, the electrical power system, and proximity sensors that tell us where our rover and drone is at any given point of time. I would now like to hand over the floor to Nithya, who will elaborate more on policy and legal aspect of our project. Thank you.
Thank you so much, Rushali. So by now, we have all seen how our rover and drone duo look like, how their hardware works, and how our mission is going to operate during those first 7 critical solves on Mars. When we succeed, this particular rover and drone duo is then going to go and explore ambitious targets like those of the lava tubes. Now let's envision that during the course of this mission, we find something so intriguing, so unique, that it completely changes what we know about science forever. Now, in such a situation, it is obviously important to know what is it that we have actually found on Mars, but we also need to understand if we have explored the Martian surface responsibly. This is where the policy and ethics section of our TP umbrella comes into picture. At the highest level, all space exploration missions must be carried out in accordance with the international law, without national appropriation, and for the benefit of all states. All these principles have been listed out in the Outer Space Treaty, or OST, of 1967. 2 provisions from within the OST are particularly important. The Article 6 of the OST talks of how all national states must take complete responsibility for all of the space exploration missions that they carry out, even the ones which are performed by private entities. While Article 9 of the OST specifically talks of how national states must take and ensure that there is no harmful contamination of outer space. We also have something which is called as the Artemis Accords from 2020, which is not legally binding, but they do promote transparency, cooperation, and responsible exploration of outer space. The Artemis Accords also do talk about having a designated plan for mitigation of orbital debris. Now, even though we have both the OST and the Artemis Accords, they do not necessarily talk about planetary protection. What about the measures that we must take into consideration when exploring different planetary surfaces or their respective moons? This is when the COSPAR policy, or the Committee on Space Research, comes into picture. Through its planetary protection policy, COSPAR establishes scientific guidelines which have been designed to prevent biological contamination of planets and their respective moons in order to preserve the integrity of future scientific investigations. This is extremely important for TP Umbrella because we are not just orbiting Mars, but also landing on the Martian surface and conducting direct exploration activities. Our mission comes under the Category 4 of the Planetary Protection Framework, with our mission objectives specifically aligned with Category 4C. This has been done in order to ensure that we take into account all of the stricter implications required, as our rover and drone duo will definitely go on to access special regions like those of lava tubes. Now, when I talk about these stricter implications, I am specifically talking about requirements that will be needed to fall under the Category 4C.
These requirements include ensuring that the bioburden limit is extremely low on the spacecraft hardware, ensuring that we have a proper organic inventory, that is the list of all of the organic constituents on the spacecraft, and trajectory biasing in order to ensure that the probability of unintended impact on Mars is extremely low for a long period of time. All these requirements are definitely going to increase the cost, thus implying that planetary protection is not free. All of the infrastructure has to be built in accordance with the planetary protection policy. However, the costs which are involved in manufacturing, testing, and integration of all these hardwares are always influenced by compliance requirements. Therefore, when we discuss about budgeting for COSPAR compliance, we are really discussing about the dedicated resources that are needed to implement these planetary protection measures effectively. These include controlled cleanroom assembly of a highest classification, that is ISO 8, having specific sterilization and bioburden reduction procedures, having specific protocols for contamination tracking and verification of the same, and also staff training, audits, and proper documentation. Thus, we can safely say that planetary protection is not just an added cost to science, but it is something that makes that science trustworthy. Now, COSPAR is not just about the beginning of the mission or what happens during the course of the mission. We also need to think about the end of life, the end of that particular mission. Even robotic missions leave environmental footprints, which include hardware that remains on the surface, certain failed elements that can cause contamination, and other risks that can affect the site for a long term. We do have the Artemis Accords that have certain different plans for mitigation of debris, but that is more specifically focused to orbital debris. Hence, when it comes to TP umbrella, end-of-life operations would include how we have a detailed mission plan to have a controlled mission closeout, ensuring that we have a maximum data downlink at the end of the mission, and avoiding unnecessary contamination and release of materials. Hence, responsible space exploration means thinking not just about this mission's success, but also of the long-term impact that we leave on the environments that we explore. And because responsible exploration must also be publicly understood, we now come to the outreach section of our TP umbrella, where we talk about what umbrella does and why it does in a certain way. The outreach strategy for TP umbrella is based on 3 specific elements. The first one being social contact, wherein we aim to establish a connection with the public by communicating the technical value to non-specialist stakeholders. The second element is the mythological branding. As you saw, our rover and drone duo, Hades and Hermes, named after the Greek gods, where Hades is our subsurface rover and Hermes is our aerial scout platform. And the last element being visual unity, wherein we have this mission patch developed, which clearly demonstrates the motto of our TP umbrella, that is Altius Vire, Altius Vola, dig deeper, fly higher. We also have a three-phase outreach execution pathway, which we have designed for our public outreach. The first phase in this is the foundational engagement, wherein we aim to have the technical progress and share that through professional platforms like LinkedIn and Instagram. The second is operational participation, wherein we will make use of dedicated outreach platforms and educational content, which will allow all of our wider audiences to engage directly with the mission and its objectives. And the third one being professional dissemination, wherein the results that we obtain, the lessons that we learn, and the scientific findings are presented through conferences and publications in order to maximize the scientific impact of our mission. To support these goals, we also have developed a dedicated website that acts as a central hub for public engagement. Over here, you can see a snippet of our website, which is interactive. This website contains tailored outreach pathways that direct different audiences, whether students, researchers, or educators, and give them the information that is relevant to them. It also includes a communication funnel that allows the visitors to submit questions and requests directly to the team, thus enabling us to respond to their questions in an effective manner. A major goal of our platform is to simplify engineering. Complex mission concepts are broken down into accessible explanations that make planetary exploration much easier to understand. The website also incorporates visual and interactive content, which has been designed to capture public imagination and make deep space exploration even more engaging. One of the major highlights of our interactive website is the Mission Customizer tool. This tool will allow the users to adjust the payload selections and mission parameters. Now, this will enable the users to understand the engineering trade-offs that mission designers face by showing how decisions affect factors such as mass, capability, and most importantly, cost. Through this strategy, we aim to maintain a constant public presence throughout the mission life cycle. And with this, I would like to call upon Louis for the concluding remarks.
Thank you, Nitya. Now, let's, after the entire year of work, we also thought about the future missions that can come out of what we have built. We imagined an agnostic swarm-type architecture to increase the rate of scientific research and data collection on the surface of Mars. I want you to try to picture a swarm of these multiple pairings of rovers and drones spread to the Martian surface, collecting and discovering its secrets at a much faster pace. So we built these robots to be able to be modular. That means that we can integrate multiple different cameras, different instruments for different purposes according to any entity that wants to use this type of technology. And we do this for exploration sites and mapping locations of interest for in situ resources, for example. And most importantly, for life detection. We plan for, this is what we ambitioned for the outcomes of our mission, to cheaply explore Mars at higher rates. So to conclude, you might ask, what are we doing with the data that we collect? Well, all core scientific data shall be publicly released. We want to maximize the global scientific impact to accelerate human Mars exploration. During the extended mission phase, the project also offers a proprietary window of third-party commercial partners that could use this dedicated time slots to give them temporary data privileges for scientific applications. So, to sum up, we have completed all these aspects of a legitimate Mars mission concept. It was a combination of disciplines, of cultures, of nations, and innovations. For 6 months, we encountered problems, procured solutions. We iterated constantly. And we are very proud of the mission concept we have built together. So please welcome my team members, starting with Asta, our electronics expert and power expert, the team member Akira, our mechanical engineer and the developer of the PASS unit deployment, Aruna, our pro coder, Avani, our project manager and systems engineer, Barney for outreach, design, and in situ resources expert, Bianca, our wonderful chief editor, David, our mission AI specialist in navigations and mission autonomy, Juliana for mission risk manager, Ken, the budgeting manager and financial expert of the mission, myself, working as a lead scientist on the aspects of the mission, Nina, our amazing systems architecture, Nitya, our cost per policy expert, Norbert, software simulation expert, Nori-san, our team legals and policy expert, Rob, our futuristic missions aspect developer, Sarah, our human system integration expert. Vanessa, the missions operation expert. Venu, the expert in mechanical engineer, developer of our CAD modeling. Vrushali, our drone and avionics engineer. And Yankit, our navigational expert. So, on the behalf of MSS26 Team Umbrella, I'm very grateful for the support and dedication of each staff member, instructor, consultant, and advisor who has offered their time, technological support, logistical support, and encouragement throughout the development of this project. We would like to further extend a special thank you to our topical advisors whose insights in space science, law, technology, engineering, mission developers have greatly helped us shape our understanding of creating a robotic scientific mission and its associated challenges. Thank you very much, and this is Team Umbrella.
Excellent. Excellent, and they were perfectly on time, which is great. So now to move on to the question phase, we're going to be having some of our faculty members to show how truly international we are. Join us via Zoom. We have, in the control booth, we got that set up. While we have that getting set up, I'm going to take the privilege to ask a couple questions. The first question I had for Luis, you described a situation where you would contract or you would sell time slots to commercial entities, and which I think is a very innovative, interesting idea. I'm wondering, have you thought about director time, kind of like what they do with observatories, where you allow free access based on some kind of director discretion?
Yes, to a certain level, yes. We still remain with the autonomy of the instruments that would be placed on Mars, but we allow some level of freedom for the third parties to use the systems on Mars, and we are also expecting these directorate or users to potentially also share that information, the data they collected, also to the scientific community.
Great, great. And I see we got Zoom working, so we're going to first call on Professor Virginia Wadring if she has any questions. And when I saw that image, the first thing I thought was when I'm using AI systems and it asks me to approve something, there gets a point I just start saying, oh, okay, right? Go ahead, And I'm wondering, have you thought about how effective the human loop aspect would be if there is a operator fatigue and they just start saying, you know what, I approved the last 100% of these, I trust AI, I'm just gonna hit okay. And at that point, it becomes fully autonomous.
Yeah, and that's actually the whole point of the human in the loop study, is to know like what's the best autonomy level and task type configuration to be able to improve like human performance. And by human performance, it's not only like response time and decision accuracy, but it's also like having a lower cognitive workload, a higher trust in autonomy. And sometimes, like when I say higher trust, it shouldn't be like a full trust in autonomy. There should be somewhat like a minimum level of human oversight. And also there is situational awareness, because as I don't know if you know this, but when we increase the level of autonomy, then we have lower situational awareness. So we need to find, the whole idea behind the study is to find that balance, between autonomy level and task type. Yeah.
Very good. Virginia, are you able to hear us now in the Zoom?
I can hear you fine.
Oh, okay. Maybe.
Sarah when she was answering.
Okay, I'll have her use my mic then.
Okay.
So you can answer her original question.
Yeah. So as far as the sample size used in this study, as I was saying earlier, it's an opportunistic sample size. So because we were 20 in the team, so that's why we decided to use a sample size of 20. It's not like based on power analysis or anything.
Okay. What portion, what fraction of the total project budget is devoted to this part, this little study?
It shouldn't be like much, because I think much of, like Ken said during the presentation, much of the budget was allocated to engineering side of the project. But like, I don't know if Ken has like more information on that.
Vanessa will be able to best answer it, but on a ballpark, it's 20%.
Okay, so the answer was that Vanessa is the one who's the perfect person to talk to for this, but ballparking, it's about 20%.
20%. Okay. Cool. And I really like the webpage that you talk about for education and public outreach. That's a nice addition to the project. Again, what fraction of the total project budget is devoted to this?
So the goal was to minimize the cost spent on the outreach. So the website was developed by us, and it didn't cost much.
We do have some budget allocated to outreach. We have dedicated outreach and client personnel included in the personnel roster, so they would be accounted for there in personnel hours.
And if you want ballpark percentages, it's roughly again 1 to 2%, which includes our mission dashboard, the website, and basically all the user interfaces, which is a subset of the personal costs.
Thank you very much. That's it for me. Good job.
Oh, okay, thank you. I think I misspoke earlier when I said 20. I didn't say 1 to 2%. Sorry. I have Patrick here who has a question as well.
Great job. So on behalf of Jay, there are two questions. You've already partially answered them, but I'll ask them again. So the first one was, what are the mission objectives if the system passes 7 sols? And what practical data will you prioritize to gather? And within how many sols?
We have the one mic that works on Zoom, so.
So the first question was about what are the mission objectives during the first 7 sols, right? No.
The afterwards.
Oh, the afterwards.
How is the data collection prioritized?
So after those 7 sols, starting from sol 8, we were allocating part of the time to these third-party entities. It will not be fully allotted to third parties. We will also have mission objectives that we can use the resources from selling these time slots and reinvest it in our scientific purposes. But Vanessa, if you can continue, please.
Yeah, I can jump in. So we have a minimum of 1 day a week reserved for our own science. Also, our operational team will be running the science that we're contracted to do for other clients. And this would enable us to reach some of those stretch goals like observing longitudes that take longer to traverse reverse towards, but could be accomplished over that longer time span where we're able to maintain our operations through commercial contracts.
Right, and the second part of the question was about what we do with the data, right? From the after missions. So that data, I briefly explained during the presentation. So it's, first is, since there are private companies and private entities that are buying these slots, we offer temporary ownership of the data. We still encourage them to publish it, but it's in order to increase the possibilities of these entities to explore according to their research purposes. We also have some to review their, let's say, conditions. But at the end, we say it again, it's temporary, because at the end we want to still publish this type of information, and we would encourage those third parties to, after processing all the data that they have, to also share it with the public.
Thank you, Professor Jay, and thank you again to Professor Jay and Ramson for all their work that they've done on this. It's really great that they advised you. I wanted to ask if Ramson has a question for the group. Yes, we hear you great.
Thank you for the question, Professor. So our integration was in different ways. So can we make some space, guys? So first thing, our rocker bogie system, which is a 6-wheel demonstration that was presented by this model, just to demonstrate how the rocker bogie systems would be. We integrated this on the NASA model over here, where we connected the locomotion system, the cameras, and there was some issue with the powers right now when we just tried to connect it. So the actual demonstration, actual movement or locomotion couldn't happen. But there was demonstration of drone, which was separate. As we are in the closed room system, we did not make it fly. We just did it, rotate it around. The small demonstration. And that's not visible to Professor on YouTube. This one's? Okay. It's okay. So this we did it separately. So instead of putting all the things in one system, we tried to put it in 3 different systems so that that could be connected, as this is just a prototype level thing. And for the demonstration of seismic sensors inside the wheel, we made a separate wheel structure in which we added the seismic sensors. Eventually, our seismic sensors, which goes for Mars, are very small in size and can be integrated in the small wheels. But the one which we purchased for prototyping were big in size, so we had to demonstrate it in a big 3D printed wheel. This was like segregated integration and demonstration.
For that, we have incorporated all of that in our simulations, as you might have seen in our presentation. And for safety purposes and on a project overall standpoint, it was best to show each and every segment as and when the presenters were talking about the respective subsystem.
All right, thank you, Professor, for the question. Yes, in this case, we tried to use the DEMI data because we couldn't get enough full data from the platform. So initially, when we were testing the results, we have all the results we got when we did some field tests outside the campus when we were using the geophones. But we couldn't install or insert some geophones in these rovers because of the challenges, some of the challenges we had during the process. But we tried to show the demonstration fully using this simulation. That's how we tried to show this. Yes, we did that before, Professor.
Analysis table.
Nine.
Is the screen visible? Yeah. Yeah.
Yeah, so these minimum and maximums are dependent on the launch costs. So we went and when we did our market research for the launchers, the cheapest we could find was that SpaceX Falcon 9 mission that carried the NASA DART satellite. And that cost around 69 million. So we took that cost and we extrapolated for our minimum cost. However, if, for example, that launcher is unavailable, then we had to model a higher cost for the launch, which we said 100 million, and that left us at 25 million for the rest of the project and the rest of the budget. Did that make sense, Professor? Okay. Yeah, it's because it's minimum and maximum with respect to launch. Sorry if that didn't. Yeah. Yeah.
What's the question?
Hardware test that you validated. How did you validate the hardware test?
Rega- Regarding the hardware structure, we would start with. So with the components, first we bought like seismic sensors. So the actual validation was done. And for the electronics components, we tried to calculate in the laboratory using the values, like inputting the values and validating the values if this with the requirements, if that was to satisfy. And for the drone and electronics, Asta, you can go first for the rover.
Yeah. And also for rover, first of all, I would like to talk about the power system. We have developed like a circuit which generates like power from the solar panels, wherein sun rays falls on the solar panels and we generated power. So these were all the hardware tests. We also tested some of the sensors like pressure, temperature, humidity sensors, as well as multispectral camera. And communication, we used XBE for our prototyping, and we have tested all those things. And for drone, I would like Rishali to answer.
Thank you, Professor, for the question. In regard to the drone, I would first like to talk about the power management system. First, we made sure what is the power required for the drone to take flight, and we measured that with multimeters. We checked the output voltage of the batteries, and then we integrated it. And regarding the communication, we made sure that we chose specific boards, like example ESP32, because it has an inbuilt communication link. Especially in the case of drone, it makes its own Wi-Fi system, and then when you connect your computer to that, you can directly send commands, and then the drone will work. So we tested all of these systems and made sure that the drone is integrated like that. Thank you.
Last thing to add in, Professor. So talking about the structure side, we could implement that our rocker bogie systems climbs 1.5 times the height it is actually. So that was implemented in this or validated. The requirement was to climb the height 1.5 times its original. That was validated in the structural perspective, and all other validations and verifications are included in the PDR also.
Okay, because I also noticed that we are missing budgets here. Link budget, data budget, power budget, and all those other stuffs. But anyway, it's okay. Well done, team. I think you are an excellent group of students. It was so nice to work with you. I have seen how much you have worked. You worked very hard, and it was so nice for me to be your supervisor. Thank you very much.
Yes, and thank you, Professor Ramson. And the students said that some aspects of the presentation that your questions you're asking are available in the PDF, and I just would encourage all of our audience to download the PDF from the library when it's up there. Huh? Oh, PDR. Oh, okay. Well, they'll show you in person later. By the way, don't try this at home. You must be a trained engineer to hold a drone like that in the presentation. Okay, for our next question, I want to ask our guest here, Professor Bernard from Netherlands.
Yes. So one advice, if you talk to an S-Tech engineer, always put a mass budget. Yeah, so it's very simple, and then that's the first thing, because it is scaling the whole complexity, the cost of the mission. So you have the very detailed cost table with 10 digits. We don't believe that. And then my question is, what is the size of the rover and the entry shield? And how does it compare to previous mission like Pathfinder or MER?
Excellent question.
For the dimensions, so actually in our interim presentation, we had the mass budget. So we thought for this final presentation, we could demonstrate and talk more about the design. But thank you, we'll keep that in mind. Moving forward to the next question, the dimensions. The dimensions are around like 60 centimeters in length, and like 40 centimeters, 60 by 40, and height is also around 40. So estimated weight could be 23.5 to 23.7 kgs in mass, and yeah, that could be the estimated dimensions of our rover. For the MER, the big Cronus, which we call the EDL system, it is actually the size of existing previous MER mission, which was for Spirit and Opportunity. So it is close to the dimensions, like almost very close to the dimensions. We changed the inner system arrangement, which could be more convenient for arranging the rover and drone inside. So the dimensions are around estimated, I might get wrong with the values, but 1.6 meters in total, the overall Cronus.
Be careful, because your rover is more the size of Pathfinder. Yes. No, the one that was launched in 96. Exactly. And so while the MER rover, they are like 2 to 1 meter, 200 kilo spacecraft, 1.5 tons. So you have to be very clear. You have a small rover, maybe with miniaturization, maybe you can do all these beautiful things. But that's maybe explaining, well, okay, low cost is reachable. I don't believe the 160 million, but lower cost is possible.
And also we had to consider the arrangement of Sorry. And also we had to consider the arrangement of the drone inside it. So, and few other factors, because we also introduced some boosters inside it. So outer dimension would be that 1.6 meters, but inside it gets smaller down, damping systems and airbags are included. And our more focus was on the sides of the rover and the drone duo. So that was our major focus, and the entire CAD details, everything is for both of them. For EDL, it was secondary, so exact dimensioning or the inside diagram is not shown in the presentation.
Okay, and I would like to ask Professor Goldman to ask some questions.
Thanks, Alvaro. Yeah, congratulations, team, for a nice presentation. That was very rich, and also I like the choreography and the climate of the team moving to the stage at the end. Yeah, well done. So you mentioned that to save cost, you will fire your team during the transit time to Mars. So that's interesting. How do you think you will regain the capabilities when the mission eventually lands? It's not so long.
I think this is a question for me. Thank you, Professor. So it wouldn't entail firing the team. This would require us being either a multi-mission company where we have multiple missions on the go, or contracting. You're talking about the transit specifically, and in that case, we're following the JUICE mission concept of operations with extremely low personnel and a lot of automation and infrequent monitoring. So we'd have 0.4 full-time employee hours during that 28.6 week transit. So yes, there is some logistical figuring out there, but it wouldn't be firing the staff. It would have to be either a larger entity in collaboration with people where we're contracting out personnel or seconding personnel to support that. Or we're a company that is doing multiple missions, and that is the only way to make this extreme low-cost operational paradigm work. I think we've lost sound online again. Can you hear me now? Can you hear me now? Okay, amazing. Sorry for the back and forth. I still might not be able to hear you all over there, but as long as you can hear me, thank you for the question, Professor. I was saying that it wouldn't entail firing people. This is the extreme low-cost paradigm of operations. So we're involving dynamic levels of autonomy here, and it would also necessitate us either having contractors, partners, where we can second personnel, or being a larger entity with multiple ongoing missions, which would be ideal for this. So you specifically asked about the transit period, which is 28.6 weeks. And during that time, we only have 0.4 full-time employee hours, which I propose being split between two people, each at 0.2 allocation. And yes, it wouldn't be firing the team, just reallocating them or contracting them out. It's the only way to make the extreme low cost work.
Because we had to reduce the quality and the testing cost, we decided to go with more with the heritage or readily available TRL6 plus level components so that we don't have to worry more about the quality and testings. To reduce the testing cost, we decided to take this more on the approach here.
Okay, but then in terms of increase of risk failure, you didn't really evaluate it, or?
So with respect to...
You go and then you go ahead first.
So with respect to the analysis based, because we are implementing budget reductions up to 75%, we were sticking to the off-the-shelf components or COTS, giving us already verified and validated components and adapting them into our systems and making sure that all the risks are taken care of was done with our risk manager, which Juliana will.
Okay, so hello, Professor. Thank you for the question. So we actually did a very deep risk analysis on the different domains of the mission, meaning that we have assessed the engineering risk, the scientific ones, also the legal. We dived into the different domains that this project is about. And it has allowed us to know what to do in the case some scenarios present failures, and we added mitigation layers to it. So, yeah, we considered, as the colleagues have said, components that are TRL6 and up as a form to mitigate probable failures from these components. That being said, that's also very well mapped on our PDR and our final report. We chose not to present them here because otherwise because of time constraint, but we have mapped 191 scenarios, and we have categorized into different severities and different likelihoods and impacts, and what would be the mitigation for each one of them. Yeah.
Okay, thank you. Not for now, for the last questions, not the least questions. We have Dr. Aurélie Thurer here.
Thank you, Anwar. So first of all, congratulations on mentioning about the human part of the missions. So I really appreciated that you mentioned about ethical aspects and trainings for the humans who will operate the crafts. I was wondering if you considered how the cosmic development goals would be kind of a way to advocate for the human presence, that the contributions to the human of the exploration.
Thank you, Professor. It's honestly a wonderful question because before we started the analysis and the heritage data understanding of our project, when we kicked it off in the month of October, we also went through the presentations by our previous alumni for the last year's TP presentation. That gave us a view of how we should essentially reach Mars, how responsibly we should do that, and how we can incorporate the previously explored CDGs, especially the fifth CDG, which involves how and what should be done. That being said, we also incorporated different ethics from the international laws, which my colleagues mentioned here, and how the human-in-the-loop testing would be done, as the human integration manager, Sarah, explored. So, yeah. Thank you so much.
Any follow-up? No? Okay, if we can just give a nice big round of applause for Team Umbrella. Excellent work. And now we're going to take our café pause. So we'll have a 20-minute break. We'll see you here in 20 minutes. Oh, yes, pictures. Just give a couple more minutes for people. So.
Testing.
I'm going to ask for 4 volunteers for determining countries. It will probably be you. So you just have to tell me a country.
You
whatever
already
you
know
want.
which country.
Yeah, I know.
Okay, Morocco, okay. Or Argentina. We prepared Argentina. Okay, Morocco,
It's
Morocco.
the future World Cup winners. I'm gonna say, of course.
Oh, really? Oh, really? Guess who I'm supporting tonight?
Portugal home last time. Okay, everyone. So now Umbrella's relaxed, huh? Yes. It's very interesting because at the beginning of this presentation, I could see all the stress across the whole room. Now I see half of the people just relaxed, no problem, smiling. There's advantage going first, huh? Okay, if the control booth, just let me know whenever we're back live. Okay. So welcome back, everyone. Thank you for joining us again this afternoon at our wonderful TP presentations here at ISU. For those who may be just joining us, we just finished our first presentation from Team Umbrella. You're welcome to rewind, watch that VOD. And now we're going to be moving on to our second presentation, which is called Roadmap. So we have our own little code names for our projects here under the TP. And again, the same format applies with our presentation followed up by questions from the faculty here at ISU. We have some faculty joining us online, so we'll try to have them ask questions first, and then we'll move on to the faculty here in the room. So without any further ado, I welcome Team Roadmap to the stage.
Thank you. Okay, good afternoon, everyone. We are the MSS26 Team Project Roadmap, aiming at creating a global communication roadmap for deep space human exploration missions, specifically trying to sustain the future of these missions. So this presentation will start off with an overview of our project. Why is it significant right now and how we approached it? We will then dive into the depths of the strategy behind our work before laying out the framework of our roadmap. Near the end, we will present the project deliverables before finishing off with concluding our presentation. So I'll start off with a short introduction. This project has been identified as a gap in the current space industry by the John Templeton Foundation, an organization funding research and public engagement by bridging right now. We're entering a new era of deep space human exploration missions. In order to understand where we're going, we must establish what space exploration means to us today. Space is considered as past the Kármán line at around 100 kilometers. Deep space astronauts will go much further than this. Historically, over 600 astronauts have flown to space. However, the biggest categories are orbital spaceflight with up to 600 individuals and commercial suborbital flight with up to 50. When we look at lunar missions, the only crewed deep space missions that have occurred to date. 28 astronauts have flown to the moon, and only 12 have walked on it. We are entering a transition from ISS testing to the Lunar Gateway and eventually to Mars. This rapid acceleration means that the way we communicate space must evolve alongside the technology. In order to appreciate the need for a new approach, let's compare the metrics between Apollo and Artemis. For Apollo 11, 600 million people watched worldwide. This accounted for around 20% of the global population at the time. Fast forward to today, where 10 to 16 million people watched Artemis 2 live. This is well under 1% of the global population. However, it does not account for the continuous tracking of the event across the mission duration and across multiple platforms. Today, we're facing a fragmented social media and streaming ecosystem. Despite this, this was NASA's biggest live-streamed event to date. The reality is we cannot compare statistics between eras anymore, but we can compare public support, awareness, and education of space exploration. We can use this shift in media to change communication methods and reinvent how the world sees and supports space. Through our literature review last semester, we investigated gaps in previous communication. Our team identified 4 key systemic gaps. The first, methodological gaps, where reliance on the deficit model has left little room for two-way dialogue. This results in, for example, taxpayers questioning why their money is being spent on space exploration rather than understanding the benefits. Second, inclusivity and accessibility gaps, defined by the systemic exclusion of diverse voices and emerging space nations. This can result in, for example, friction between indigenous populations and space corporations when land is being used to build ground-based observation equipment. Thirdly, transparency and feasibility gaps, which highlight the gap between our high aspirations and the technical and political reality. We need to learn how to effectively convey this, and without addressing this issue, we consequentially see the public negatively react to malfunctions during design test stages, who then connotate this with failure and waste of taxpayer money. Lastly, narrative and structural gaps, driven by the multiple competing framings of space, which then confuse the public. Most recently, this can be seen in the debate for our purpose for deep space human exploration and what benefits we're truly hoping to achieve. These gaps led to our TEI-TAS pillars: tangibility, equity, inclusion, transparency, accountability, and sustainability. These pillars serve as the values and priorities that all future space communications should follow in order to build a lasting connection between space policymakers and civil society. So guided by these values, the objective of our project was to create an adaptable global communication framework for deep space human exploration missions, specifically trying to enhance awareness, education, and long-term support. In order to do this, we created 3 deliverables. First up, the Roadmap tool, a digital platform that combined communication media, tailored communication strategies, and key stakeholders of global nations. This digital platform will serve as an updated resource throughout the roadmap's timeline. Secondly, the campaign, an example marketing strategy for our roadmap that emphasizes the need and relatability of space exploration. This is a short, memorable, yet flexible concept that can be taken and adapted across nations. Last up, our Why Space Matters podcast, an example of initiating the discussion of a transition in the space communication sector between existing space actors. It's an implementation of two-way communication through modern media and a means of spreading awareness of our roadmap through ISU's network and further. So last up, we used ISU's network to gain expert advice to gain insight into our theorized gaps in the space communication sector. We consulted experts categorized into general, podcast, strategy, and culture. Through these interviews, they stressed several crucial points. Some of these were that communication must drive action and accountability. We now need to shift from exploration to utilization using storytelling. We need to humanize the narrative and also focus on active listener engagement and feedback loops. And finally, the importance of unified human values must be stressed, incorporating history and culture in the way that we communicate space. So with this foundational framework and expert validation established, I'll now pass on to Ruchira, who will take you through what all of this led up to, the strategy behind our roadmap.
Thank you, Sia. Global initiatives like the Communication Roadmap do not solely rely on their technical milestones. They equally rely on the public support that they gain. And the strategy that we designed here aims to do the same. During the literature review phase, we realized that the strategy is based in 5 layers. First is the substance layer. Now, before we even start catering to the audience, we need to understand why they would care and what they believe in. And to do so, we need to use the science and engineering application layer. Then we have the tangibility layer. In this, a general public would majoritarily care about human performance risk developed by deep space exploration missions, rather than caring about the space infrastructure itself. So we leverage the human performance and life sciences. Third is the translation layer. Now, just being technically sound and socially not so aware does not help. Hence, we leverage the space humanities layer to translate the ethics, moral, and values so that the narrative that we set resonates across the societies. Then we have the delivery layer. Now it is important that the vision that we set also turns into an operational roadmap through public-private partnerships and transparent implementation. And in this, we leverage the management and business aspect. Lastly, we have the legitimacy layer, where we make sure that the narrative that we set does not focus on saying that space is a luxury, but rather focuses on saying that it is a responsible and sustainable approach for human exploration. Once this layer were put into place, we then realized that how can we make this roadmap acceptable at a global state? Hence, we created the global divide of nations into 4 tiers. These tiers are made based on their space capabilities, as well as taking consideration the downstream and upstream applications. First, we have the Tier 1 nations, which are the high-income nations. They have their own orbital launch capacities, as well as the human spaceflight programs, like US, Canada, and UK. Tier 2 are the ones that are expanding the sector through satellite manufacturing, as well as the international lunar collaboration, nations like Brazil. Tier 3 are the nations that actually use the satellite applications, like Egypt and Vietnam. Now, India is a very interesting case because fundamentally it is a Tier 3 nation, but in terms of space capabilities, it is Tier 1. Lastly, we have the Tier 4 nations. These are the ones that are our end users and host the ground station. Once we dealt with the problem of making this roadmap acceptable globally, now we realized that there was a common link among them, which was the 7 key stakeholders, which would now help us to translate and implement this roadmap. First being the government. They have been setting the budget and political view shaping the direction of space exploration. Then we have the agencies, forever being the institutional phase, generating stories of space exploration and setting the narratives. Then we have the private companies, which are now coming into picture and leveraging the commercial channels, carrying out accountability and making sure that it does not resonate with their reputation. Then we have the academia, which is the most trusted of all the 7 key stakeholders because they provide the knowledge that answers or justifies the why of this project. Then we have the investors. This justify saying that space is now a viable economic frontier and not just a playground for space agencies. Then we have the international institutions like UNOSA, who set the governance framework so that initiatives like ours, the Global Communication Roadmap, can become politically neutral and geographically inclusive. Lastly, we have the NGOs. Now, this is the most important link because they are the ones who are connected to the communities that are excluded. So, their inclusion here is not just mere gesture, it's a standard requirement. Once we figured out the 7 key stakeholders, now was the time to move to the actual audience that was the general public. While doing the literature review, we realized that all the existing toolkits have an assumption that general public is just one segment of the audience. We did not want to take this approach and hence came up with the sentiment knowledge matrix. Here, we used segmentation of 9 boxes, which we came to conclusion based on 2 things. First, the emotional attachment of the audience. Are they for, against, or neutral of space exploration? And the second was their knowledge base, which was indicated in terms of low, medium, and high. For example, we can see the box 2, which is unaware. This is the largest segment globally present and absent from space engagement. We need to bring them back into the dialogue. Then we have box 7, which is the critique. They are aware and supporters, but they do not align with the values. So giving them more facts and figures is not going to work. It might just backfire. So we need to start a conversation with them. Lastly, we have the champion, which is the box 9, the ultimate goal that the roadmap is trying to reach. These will become the space advocates that will exist for long-term public support, irrespective of the political cycles and generational shifts. Once we segmented the audience, now the question arises, how do we make the roadmap relevant, implementable, and unique than the toolkits that already exist? So we took the approach of educating the educators, where we are dealing with the space professionals and making them aware to hold the audience in order to communicate with them. And hence, one of our deliverable is Why Space Matters podcast. Then to make the project or the space make more like day-to-day topic, to promote this, we came up with a campaign called Beyond Earth for Earth campaign. And most importantly, to make sure that the roadmap stays relevant across all the years that we have mentioned and is reviewed to stay implementable, we came up with the MEAL framework, which is monitoring, evaluation, accountability, and learning framework. Said so, I want to reiterate that we did not completely reinvent the wheel. Of course, we leveraged the existing toolkits, made our own additions, and aligned them in order to make the roadmap operational. Now, I would like to call upon Ben to actually explain the roadmap.
Thank you, Chair. So now that we've explained why space matters, why public trust matters, as well as why the strategic framework that we've established is needed, we're going to get to the meat of the actual presentation and our project, which is the communication roadmap. This is where we're going to move from analysis of everything we've done so far to the implementation of all of that knowledge that we've gathered. Public support for deep space exploration cannot be built just by a single campaign or one agency or a single moment. It needs to be built through a sustainable communication architecture. Our roadmap is designed to act as a long-term 3-phase structure, which moves global audiences from basic awareness to informed understanding, as well as finally active long-term participation and stewardship towards deep space exploration. We include 91 specific strategies that are distributed across stakeholders and national capability tiers, audience segments, age cohorts, as well as ethical communication pillars that we've all mentioned before. The goal is not just to make people excited about space, but to make space exploration more understandable, relevant, trustworthy, inclusive, as well as accountable over time and around the world. Looking at the risks that we've identified with relation to just general communication, the main ones are perception, communication, ethics, and politics. Looking at the risk of perception, we have seen that many people perceive space exploration as expensive, distant, and disconnected from Earth and their day-to-day lives. So instead of just saying space is amazing, trust me, we need to demonstrate as communicators how the health, climate monitoring, disaster response, navigation, economic development, and various other advantages that we all know actually impact their lives and kind of connects the two dots for them. Then looking at the risks related to communication, space is a very complex topic. It's to communicate. So especially in a fragmented media environment, as Sia has outlined, it's a very delicate balance between giving a technical explanation that's too technical and will not be able to reach everyone versus an oversimplified explanation that has a lot of assumptions which might lead to distrust or maybe even misinformation in some cases. So in order to address this properly, we need to use the right media channels, the right languages, and the right approaches to reach specific audiences while keeping ourselves open enough to be able to adapt to different audiences or different stakeholders. Looking at the risks related to ethics, the space narrative can very easily become filled with greenwashing. So including various groups just for symbolism and without actually really incorporating their opinions and values and beliefs. So our roadmap really emphasizes and has a variety of strategies that encourage genuine participation and inclusion, as well as some anti-greenwashing measures to make sure that it doesn't happen. Communicators shouldn't just claim the benefits to humanity and the benefits to various groups, thus trying to include them. They actually need to prove that these benefits impact all groups that are involved and make sure that they are thus involved properly. Then finally, looking at the political risks, without care, a lot of the communication narratives can very easily be dominated by powerful countries, agencies, or even powerful private companies, as we are seeing in some cases. So our roadmap uses a variety of strategies related to cultural, common heritage framing, as well as agency alignment, creating a global narrative, and keeping space exploration connected to a shared human responsibility versus competition between various stakeholders that are trying to communicate a lot of the same things, just putting their agenda on it. So we want to avoid that. Our roadmap has a three-phase structure. The first phase is about raising awareness. The second phase is about creating more educated people in the realm of space exploration, as well as engaging them in various activities so that they become involved more directly in space and space exploration. And finally, we want to foster long-term care and investment and activity and just general stewardship towards space exploration amongst the general public. The phases of the entire roadmap don't follow a strict sequence. They have spans of years, as you can see. So the first phase is around 1 to 2 years long, depending on various scenarios, the country specifically. Then phase 2 starts at around 3 years and goes on to around years 7 to 8. And that's where it really comes to fruition, while phase 3 starts from around year 10 and goes on as long as the roadmap keeps being implemented. And we do have that in mind where, as I will show in the last phase, we have strategies that go on indefinitely and do not have a definite end. So this overlap is intentional. It allows for various phases to be more fluid, making them more applicable and more adaptable to all the variety of scenarios and countries and audiences that are out there in the world, while keeping it relevant and keeping it useful and still structured in a way. So looking at the first phase, which is about raising awareness, the goal here is not to create immediate deep behavioral change. It's too quick, too sudden, too immediate. It wouldn't be possible. So we must first orient, engage, and prepare the current general public for future investment further along the roadmap by helping them understand what is going on and what's happening and making them aware. So some of the examples of the 37 total strategies we have for this phase are listed on the board. The first one is orienting the ecosystem through tier segmentation and country overview. The goal here is that various governments and institutions who all act as communicators need to understand and orient themselves within their country-specific space environment, as well as they're seeing their place and how that all fits into the global space environment. Because they need to be aware how they can communicate effectively. A country that has a large space agency for a long time is going to communicate very, very differently to a country that has no space agency. So you need to be aware and you need to establish where you are. This way, our roadmap can also avoid a one-size-fits-all approach where the roadmap would kind of do the same thing for all different scenarios, which would make it pretty useless. So we tried to avoid that with this strategy. Then our next example is the shared narrative anchor. We want deep space exploration to be connected to tangible benefits on Earth, making it directly applicable to everyone's or many people's lives, and make that a narrative anchor in the sense that it's something that's communicated across the board. No matter where you are, you have different benefits that you're getting from it, so that is something that should be communicated. The next example is the trusted voice identification and cultivation strategy, which involves using already trusted communicators as some of our main sources and main platforms for communicating information. So institutional voices, let's say like a government or just a space agency representative, are often not enough as a sole communicator to deliver a message. We need to have trusted voices deliver a lot of these messages to reach as many people as possible effectively, such as educators, scientists, journalists, public figures, local advocates, or cultural leaders, as they know their audience, they know their targets. Then finally on this slide, we have the No Country Left Behind strategy, which is one of our inclusive launch principles, meaning that especially focusing on tier 3 and tier 4 countries that are less space involved as of right now, are not left behind and not excluded. It's much harder for these countries to establish initial contact and raise initial awareness about space since they have not done it so far, which doesn't mean that they can't do it in the future, but the idea is that with the No Country Left Behind principle, they are allowed to and they are encouraged to establish their own narrative straight from the beginning, as opposed to having a narrative forced onto them by someone else, a bigger country, more relevant space agency, so that they can have their own specific identity and carry that through all the different phases also as they move up the tiers. Overall, phase 1's aim is to create a foundation. It maps the ecosystem, it builds a shared narrative, it identifies credible messengers, and prioritizes inclusion of everyone from day one. Then phase 2, looking at the education and outreach and creating outreach opportunities for the general public, has the purpose of moving people from aware to informed and having a capacity to understand what is going on. So the idea is that once people hear a message related to any sort of space exploration topic, they will understand it and they can engage with it, as opposed to just being aware about, okay, this thing is happening, but I don't really know what it is. I don't really understand it. So some of the example strategies that we have here out of the 36 strategies for this specific phase are moving people from aware to informed through standardized curriculums. The idea here is that space communication shouldn't only happen right when the mission is happening or at a specific time point in the mission. It should be kind of preceded. You should talk about it earlier, ideally 1 to 2 years earlier, obviously not only focus on it, but mention it so that by the time the mission actually comes along, people are aware of its significance. They know why it's happening, they know what's going on, they know what's at stake. They're not only finding about it in the moment or right after it happened. This way, they can actually engage, and again, this is what this phase is trying to do. Our second example is STEAM integration. So this comes from the acronym of STEM, but adding arts as well as a sub kind of topic of arts or sub fields of arts, the humanities and social sciences. It's important that these fields are also integrated into communication, and they need to be addressed in order to make sure that all all parts of the audience and general public can actually receive and be receptive to anything that you're trying to communicate. Otherwise, you're missing a pretty big chunk. Then a third example is NGO-led equity reach. As we've mentioned before, NGOs are uniquely positioned in a lot of communication paths, essentially, because they are already trusted and they're already in contact with a lot of really specific groups that are very often hard to reach. So if you can have NGOs collaborate with you and just generally collaborate amongst one another to deliver a targeted and coordinated communication strategy, they can do this much more effectively if they each communicate with their own their own specific segments of the audience versus kind of doing it all over the place. So it's similar to the trusted communication sources that I mentioned previously with phase 1, but more specific. Then finally, we have the two-way communication channels, which aim to establish a feedback loop. And this is something we've mentioned many times, that currently, very often, space communication is kind of like a one-way stream where information is just dumped onto the general public and put out there. And then if you're receptive, if you know what's going on, and you've already had your own education about the topic, you'll understand it. But if you haven't, which is a large majority of people, as I'm pretty sure everyone in this room is aware, it's not going to work. So you need to have two-way communication for just to be able to address things that might not be clear, might not be respected, or might not be delivered properly. Again, this is one of our main strategies. So overall, phase 2 expands the role of space agencies, international institutions, and private companies to make them more effective as stakeholders of communication and not just stakeholders of space exploration. So phase 1 tries to answer, why should I care? Phase 2 tries to fill and answer that with, how can I understand this, teach this, and participate in this? Then looking at phase 3, this is where we aim to establish long-term support and stewardship indefinitely, as long as the roadmap is maintained. The four examples here out of the 18 strategies that we have are global space exploration, air communication guidelines, which would be a framework aiming to communicate across all stages of missions effectively. So this includes pre-launch, launch, active exploration, return, as well as post-mission. Very often, attention for a mission or towards a mission spikes either at launch or active exploration and kind of dies down afterwards because you've had your moment and you kind of lost it because it just peaked. You don't carry that momentum through. So this is something that should be done across the board with a lot of missions. And so once people are much more educated and there's more outreach opportunities, this is easier to do, which is why it's in phase 3. The second example is transparent data and communication infrastructure. So often data and just information related to missions is not super clearly communicated. So doing this in a much more transparent way, creating a tool that would allow the public to see mission status, technical progress, budget use, practical applications, as well as mission data, would ensure a lot more transparency and create a long-term trust between the general public and various institutions and stakeholders, allowing this continued stewardship and engagement. Then the third example is the annual Space Forum, which, as the name suggests, would be a yearly opportunity for essentially all stakeholders to discuss amongst one another. So this would involve governments, space agencies, companies, academics, NGOs, traditional communities, as well as the general public, to talk about the concerns they might have, things they like, things they want to see, so that there is a continued two-way communication and continued two-way discussion. Then the last example is the 4-year global review cycle, which is based on the fact that a lot of governments and a lot of politics revolves around 4-year cycles. So if we want a roadmap to stay relevant and be indefinitely implemented over a long term, it also needs to be able to conform to these 4-year cycles. Global politics, as well as technologies, public values, and sustainability concerns change as governments come and go. So our roadmap needs to be able to conform and address these cyclic changes. Phase 3, on top of these strategies, also includes some anti-greenwashing measures, audit systems, resource extraction limits, data sovereignty frameworks, as well as other things. The goal is that together all these mechanisms aim to ensure sustained public trust and sustained stewardship, as opposed to the previous phases that have more of a beginning and end goal. Looking at the synthesis of how all these strategies fit together and everything that they address, the total 91 strategies form a very structured system that is structured in a specific way to be able to address almost everyone equally, but there's still some focuses that I'm going to talk about here. While the roadmap has very broad applicability, as you can see that almost every category has at least one strategy, but a lot of categories have a substantial amount of strategies dedicated to them. The idea is that all national tiers, which each have have cohorts from A to C, and each have people that support, are neutral, or are against space exploration, need to be able to be addressed. So as we can see here, the structure, for example, for the cohort strategy distribution is that most strategies focus on adults, so working adults. These people are the ones who regularly vote, work, and lead organizations. So they need to be directly addressed in order to be able to create meaningful change and drive any point home. Then at the same time, cohort A, so young people who are about to become adults, also need to be addressed, but they are addressed through a different set of strategies, because for them the goal is a lot more to create early awareness and early education so that when they do transition into cohort B, they can be much more directly and effectively targeted. Finally, cohort C, so older people, are still addressed, but they have less of a direct focus, as their role for the most part, while they do vote and do have big influence on various policy changes, it is often harder if they did not have the previous phases, they didn't personally go through the previous phases to address them directly. Yes. Then also looking at the SKM segmentation, so all the different types of audiences, so people who are for, against, and all the subtypes, as already mentioned, are also addressed relatively equally. Looking at the next set of analytics, we can see that of the 91 strategies, 89% of them are applicable to all types of national tiers. So every country, depending on, or independent of whether they are very involved in space or not involved in space whatsoever, can use these strategies, which makes the roadmap very widely applicable. The few strategies that aren't in this 89% are strategies that need high levels of technology, so things that need more development. But obviously, as you move up the tiers, you can implement every single strategy that we've thought of. We can also see from the TEI, TAS pillars on the bottom that there's a shift in focus as we move through the phases. At the beginning, there's a lot more of a focus on inclusion, tangibility, and equity to raise awareness, education, and create outreach opportunities, while later on in phase 3, in the long term, we want transparency, accountability, and sustainability to also gain a massive focus in a sustained way. Finally, the roadmap also includes essentially a measurement logic in and of itself, which allows for phase-specific KPIs that are listed on the slide to be connected to all the phases and allow us to, or any implementer, to measure the effects and the performance of the roadmap. So for phase 1, we look at how people, the general public, transfers from non-aware to a sympathetic observer, which means someone who is neutral or ideally supportive of space exploration. As well, and then for phase 2, we look at how these now aware people move to an informed understanding status, meaning that they actually understand and are able to directly engage with anything that's communicated to them, as opposed to just being aware of it, or maybe even just being in support of it. You might not necessarily know what's going on just because you support it. And then for phase 3, we look at, again, this long-term sustained institutionalized trust and stewardship engagement. So we want people to be able to be trusting towards all the different communicating stakeholders and maintain that trust and want to engage in various stewardship-related activities. Overall, all these measurements allow for us to, or any implementer, to not have to redesign the entire strategy and the entire roadmap just because something's underperforming. Looking at the KPIs, you can see and you can kind of pinpoint out which strategies might need some tweaking or might need to be changed to create more effective results. And so you can have much more targeted restructuring of the roadmap or just implementation of the roadmap as opposed to redoing the entire thing or creating a whole new campaign. So now, to see how all of this can be implemented in some ways in the real world, I'm going to ask Michael to join me here on the stage.
Thanks so much, Ben. Well. So, for demonstrating the roadmap, now that we have seen the theory behind it, our TP has prepared 3 different products for the 3 different phases that we just mentioned, so you can see how we could actually activate it. These are just examples, but it's a nice guiding for anyone that wants to activate our roadmap. So first of all, for the first phase, awareness, we have called this phase Unlocking Space, because we want to see how we can approach each one of these stakeholders in different countries with our strategy. 91 strategies. Those are a lot of strategies. So if someone actually wants to use our roadmap, they need some instructions or, I don't know, like one of these old phone books. But of course, we are not that inconsiderate, and we have developed a digital tool, because we are in the age of technology. Now, I'm going to ask someone to tell me a country so we can see how this tool actually works. Please, Professor Anwar.
Okay, yes, we'll have to support the Atlas Lions, so I'll choose Morocco.
Yeah. Perfect. Okay, so if we go to Morocco here in the tool, the first thing they are going to see, it's a dossier with all the information that we have gathered through the year. We have a bunch of information for every single country in the world. First, we can see some of the demographics, because of course our roadmap will change depending if we are communicated to some young population, with a country with like a very young population, or a country that is very aged. It will change the strategies that we have to activate. So first, we have some of the demographics here. Then, very importantly, in the second tab, we have some space information. Has this country has a space agency? Have they launched satellites? Do they even know what is space or what is happening in space? This, of course, is one of the most important parts, to know who are we communicating to and which way we have to communicate. Then, the communications tab tells us about which channels are best to use in that specific country. Maybe that country has most use of Facebook, or some of the social media that are used nowadays are forbidden in that country, or are not used that much. So with this information, we can know what do we have to use. And finally, in the stakeholders tab, we have gathered some of the most important stakeholders in each and every country. So you have a first way of approaching the country and to know like who the principal communicators on that country are, so you can contact them and actually leverage these strategies. If we go to the strategy studio, we can personalize our strategy. This allows us to select who are we communicating to and with aim we are communicating. It's not the same to do like a policy brief that actually like you just want to do youth outreach. And if we generate this strategy, what we are going to see first is the context of the country, what we saw before, like what are the demographics, if something is happening, if they have any space information at all. Then, if we go to the first 12 months, this is something that is fairly common for every country in this tool, and the first thing that anyone has to do when they want to activate our roadmap is to contact and activate these stakeholders that we are giving, as well as searching for more stakeholders, because of course we haven't found all the stakeholders in every single country, just the most important ones, but there's probably more like social media influencers that you could actually use for this roadmap. Then if we go to the roadmap tab, we will see the 50-year-old strategy, personalized for this specific country depending on the context. Here you have all the information you need, and the strategies filter out only the strategies that you need to activate for that specific country. And finally, we have the channels and the stakeholders that that country mainly use. This depends on the internet connection that is available in that country, the press freedom. We have mapped everything out so you can know how to communicate properly. And of course, there's, as you saw before in our presentation, there's a lot of complex words that many people might not be familiar with. So for solving this issue and that to allow anyone to actually use our tool, we have developed an AI model which you can ask in natural language. So if you don't understand something from the strategy, you can actually ask the model here and it will actually reply to you with all the information you need. This is very useful for us in terms of like actually making the tool accessible for anyone that wants to use it. So once we know who are we communicating to and what we want to communicate and how we want to do it, we can go to the next phase, which is education and outreach. We have called this phase Space Nice to Meet You. Now we know who we want to communicate, right? But we need to know how to do it. And for doing this, I really like this phrase, that is that you will never have a second chance to make a good first impression. It's very important that your brand, the image of your brand is very good, memorable, short, and that the people actually feels connected to. So for this, we have based our brand image, or this example of a campaign that we are developing, in 4 communication pillars. The first pillar, space supports life on Earth. Everything that we are doing out there is to bring benefits back here. Secondly, we have that exploration is a human story. Humanity, or the human history, has been always driven by curiosity, and we want to leverage that. Third, we have that the future should include everyone. This is all about inclusion. Everyone in the world should feel that is part of this story. And finally, what happens far away can matter close to home. This is a phrase that encapsulates all the other 3 pillars and that we are using in our strategy. So with all of this, we have developed a potential logo and a phrase that could be used in our campaign. This is just an example of how we could actually leverage all these communication pillars. We have the logo that I will explain, and we have the motto, Beyond Earth, for Earth. Short, memorable, and actually encompass everything I just said. We are going far away, but everything we are doing is for the sake of Earth. So now, talking about the logo, we have first the compass, direction. We are all moving in the same direction with the same objective. Then, the rocket, technology, advancement. This is what space is. We want to use the technology that is in space to actually bring benefits back to the Earth, back to the world, the inclusivity. Everyone is part of the same story, everyone is part of this mission, and everyone should benefit from these space advancements. So for now, I'm going to show you an example of how a campaign message, what a campaign's message could be. So for example, the message that you want to promote in a country could be that space is crucial in your everyday life. And for doing this, nowadays, with social media and all this, attention span dropping drastically, of course you want to be as visual and as attention-seeking as possible, but also trying to be truthful and trying to actually convey the message that you want to convey, right? So if you do something like this, imagine that you are in a highway driving, you have 3 seconds to actually read this billboard. If you put all this text in the billboard, probably the person that has just drive past will forget after 3 seconds, and when they arrive home, they will not even remember what it was about. Or they could try to read it and actually cause an accident, which we don't want that, right? So what we tried to do with our campaign was to actually avoid that. Make it simple, but make it effective. So we developed this. This is a campaign that is trying to convey the benefits of space. So we have tried to make a contrast, an image that conveys the wonders of space. Space is beautiful, and it's beautiful for every human and every culture. And a seemingly unrelated object that you might be using in your everyday life. In this case, a water filter, but that not many people know it's a spin-off from a space technology. And that's what we are trying to do. Many people, when they see these 2 images together, they might not find the connection, but that will cause curiosity. And that's what we want to do. We want the people to be proactive about thinking, why are these 2 objects together, and try to find more information. That's how we take the people in and making them proactive about searching about this. And it's not only water filters, we could use more objects like noise-canceling headphones or anti-scratch glasses. Of course, if these objects were to disappear tomorrow, it wouldn't cause much of an impact, but it's a nice example on how space is in our everyday life, and how if space were to disappear, it will not because of these objects, but because everything that it represents, it will cause the downfall of society. And that's what the people needs to know. Space is very important. So that leads us to the third phase, where we want the people to say, I can't live without you. I can live without space. And on this phase, the example that we have used on how to actually activate this long-term support is the podcast. The first thing we did is to map out every space podcast that was out there. And what we realized is that this podcast, all of them talk about what is happening on space or why space is cool. But there's not a single podcast that talk about how to communicate space. So that's our objective. And for doing this, if you remember our literature review, we talk about the deficit model and how this is an outdated way of communicating and how we should transition to the 2-way communication. So with this in mind, we ask questions in the ISU social media for the people to feel part of the conversation. Questions like why space matters or when commercial flights will be available were included in our podcast interview with our 2 experts. First of all, Dr. Pascal Ehrenfreund and Dr. Walter Peters. In our first episode, with Dr. Pascal, we talk about inclusivity and how international cooperation is crucial for space missions. In our second episode with Dr. Walter Peters, we talk about how important space is and how if space were to disappear tomorrow, it would cause the downfall of society in no more than 10 days. The statistics tell us the whole story. in just 2 weeks of the episodes being published, and with no budget allocated for these episodes, just organic marketing, we managed to get more than 6,000 views. And we managed our objective, that it was to actually engage the space society, because this was meant for them. We wanted the space sector to know how to communicate space and to know the importance of communicating space properly. This we managed on LinkedIn with a click rate superior to the 7%, which is very good for this type of content. Of course, there's room for improvement, and the next time we actually publish something, we will try to publish more shorts or more content, so the algorithm of social media actually favors our visibility out there. But that's something that we can still do in the future, so we will manage for sure. Now, I will pass the mic to Darius so he can conclude our presentation.
Thank you, Michael. So, in order to conclude our whole roadmap, which we put a lot of work into, I'm going to go over the main parts of it first. So we have the main gaps that we have encountered. So we have that one-way communication, which is where we are broadcasting that information. We're not having that two-way dialogue, which we have stated is very important. Then we have that fragmented media. We have all these new technologies, all these new medias, but we still use old strategies from old eras not aimed towards a modern audience. And we have that absence of planetary identity. This right here is where we have those stakeholders that have their own specific agendas, be it geopolitical, cultural, religious, you name it. All of these are creating a very huge gap in between the ones who hold the knowledge, so the 7 active stakeholders, and the ones we want to pass that knowledge onto, the general public. So this is what we built in order to bridge that gap. So we have that interactive tool, the tool that Michael showed you. This is the blueprint. This helps create that blueprint to help build that bridge. It provides you those specific strategies for those specific stakeholders directed towards their own specific audiences. And when you have those specific strategies, then you can actually build that bridge. And in order to stress test this bridge, you need to have a tool like a podcast, for example, that can help give you the statistics and the metrics to give you that feedback in order to, give you that feedback on the stability of that bridge, right? So our universal strategies helps create a plan for those stakeholders, those countries, and those audiences, which then can be used in our phased framework. So phase 1, awareness. This is that first point of contact. This right here builds that trust, builds that relationship so that you are able to effectively communicate about the benefits of deep space travel. And then we have that education and outreach. This is where you provide and establish effective communication towards different audiences using directed channels. And these two right here, they are the hard work. This is where everything is put into to build that bridge. And then you have that support and you have that trust and you give that guidance through the education and outreach. Now you need to have that long-term support, maintaining that support for space and ensuring that that bridge is there and stable so that communication and messages can keep going back and forth between the stakeholder and the general public. So, to sum everything up that we did here today, right now, space is way too overcomplicated and it is causing a lot of communication gaps in the space industry. But we have the blueprints, we have the plans, we have the roadmap that can help build that bridge. We have the tools, we have the strategies, we have the podcast that helps, that proves that it can work, and it proves that the communication of deep space exploration and the benefits that come with it does not have to be complicated. So, if you want to use, our tool and as well as our strategies, please contact us, and we are more than willing to help you create your own communication bridge directed towards the most important stakeholder, the general public. I would like to give my acknowledgements and my thanks towards Dr. Virginia Warching and Dr. Arlie Truer for their direct supervision of the roadmap, as well as all the experts who helped give their advice and their expertise throughout all 3 phases of our project. We could not have done it without them. As well as John Templeton Foundation and the International Space University for their contributions and also their support as well. And I'd like to give a shout out to everybody here in the audience. Thank you for being here today and giving your time and effort and your ears, and everybody online as well. But most importantly, I want to thank my team, which I want to call down here now, every single one of y'all. So these guys, throughout the 9 months, have put their blood, sweat, and tears into this specific project. And this is something that I think will actually be useful and can be used for the future of the space industry. But yeah, thank you. Questions?
Well, like they say in Morocco, tabarak alaikum, or bravo in Italian. Very good job. Excellent work, guys, and we're going to go into the question phase now. And since we have one of the podcast guests on here, I'm going to flip the script a little bit. Instead of him asking a question, I'm going to ask him a question, if he doesn't mind answering. What was it like being on the podcast?
Interesting, maybe a little bit long, to be very honest. And that I'm turning it around. That was already my question, by the way, because you present, by the way, good presentation and good work. Also, let's say on behalf of being the co-PI of the John Templeton grant, so this is really respecting what we were looking for. So very good. Now, on the podcast, there was one thing that really struck me is that you were really mentioning the reduced attention span. And I'm talking about the average person. I'm not talking about certain presidents. If you have an article in Space News, for instance, you have the full article, and on the side you sometimes have these blurs, these important things that somebody has said, or during a conference or something like that. These really highlights. Have you thought about how you could use this podcast of 60 minutes by extracts, which you can somewhere distribute in 3-4 minutes?
Thank you for the question, Dr. Walter Peters.
Oh, I see.
I think that you have to talk on this
one. Yeah, I think that we definitely... we definitely considered that. We wanted to make sure that, this podcast is 60 minutes long, and there's only a few dedicated people who are going to listen to it, who are actually already kind of invested anyway. So we made sure, I think that we distributed Instagram Reels and YouTube Shorts of these 60-second clips of the most important pieces. That was a big part for us. I think that we could have done a few more, actually, but that was where we got the most engagement, absolutely, 100%. Because very few people were going to watch 60 full minutes. No one's got that kind of time. We're busy people.
Thank you. You have a follow-up? No? Okay, and so before I ask on Professor Virginia Warting for her question, just to be in the spirit of the team roadmap, we have a question that came in via YouTube from a global faculty member from ISU, Dr. Juan de Dalum. Huh? Okay, I need to work on my Spanish. He says, congratulations on having already started with the pilot communication actions, such as your Why Space Matters podcast. So he sends congratulations. Then he says he's been able to watch the chapters of the podcasts, but he wanted to ask you specifically, what have you learned from it, And based on your learning, how do you envision the next steps for your podcast? Maybe Gio?
Maybe the group of podcast.
Oh, okay, sorry.
Okay, you wanna?
I mean, I can answer some of it. So from the experience of the podcast, I think it was very good. I got to ask like a lot of really good questions with my co-host Nikki online. Maybe you also want to add in on some of your thoughts as well. But I think it is a very good opportunity to actually get some people who have been very involved in the space industry and who help actually direct it in a very unique way, and getting their actual insights on specifically how to communicate about it is very impactful and I think priceless. Nikki?
Yeah, can you guys hear me?
Yeah.
Yes. Okay, yeah. I think one of the coolest aspects of our podcast so far was getting the different backgrounds. So we had Dr. Aaron Freund and Dr. Walter Peters, with Dr. Walter Peters having a more economics background and Dr. Aaron Freund having a more scientific background. It was really cool to see how they have different perspectives on communications and the space sector as a whole and its benefits to society. And I think moving forward, if we can get more guests from different backgrounds, then we can continue to have these different perspectives.
Nice, thank you. Special edition of Why Space Matter podcast coming live. So now moving on to our esteemed Professor Virginia Warching. Do you have a question for the team?
Of course I do, but first I have congratulations on a job well done. Very good presentation today, very effective. I have a question about your activities in phase 3 that you described on slide 22. You were proposing some kind of a meeting, not a conference, but more a stakeholder kind of a meeting, is what it sounded like. And I'm wondering about adding yet another meeting to the world of space meetings. There's already a lot of them. And some of them are pretty expensive to attend. How would this be funded? Are you putting in funding barriers to some of the people that you'd like to attend? How would this work?
Who's grabbing this?
You want to answer? So we put in annual space forum to put into perspective the point that we need people to gather and create this dialogue so that we can communicate and understand the actual need of the audience. We understand that there already exists a number of conferences and public gatherings as well. But the key difference here we want to highlight is that these conferences that we attend actually involve already enriched space professionals. There is no engagement of actual public attending these conferences. So when we say that we want to do an annual space forum, we are mostly highlighting that this would be open to public and their engagement rather than just space experts coming in together to share their knowledge. So that was the new perspective we were trying to bring in, more public engagement, more generic so that people can understand the basics and not just scientific discussions. So that's what we wanted to add the space forum.
And that's a great idea. I'm questioning the economics of it. And let me make a suggestion. Would it be maybe more effective to work with an existing space conference, and your project could make some kind of a way for the public to attend it and have some additional material presented toward them?
Yes, absolutely. Aligning to what you said, we already are aware of a few initiatives like in Luxembourg especially, there is Orbital Launch, which hosts gatherings for general public. It's a cafe, and they have discussions with scientists and people very generically. So initially, to start with, this could be the approach where the public reserves a seat for a minimum amount and gets to experience or talk to the experts in the community. And then eventually, when it builds up momentum, we can figure out how to monetize it. But to begin with, we can definitely start with those initiatives.
I think that's worth exploring. The ISS R&D conference has a category of attendee for K through 12 teachers. That's just a couple $100 for registration, and a teacher can go learn everything about space and then turn around and deliver the material in their classroom that year. Super effective, really powerful. You might look at that as a model for what you want to do. And that's my only question. Thank you so much for the very good presentation.
Yes, thank you, Professor. And now going to your teammate on supervising, Dr. Aurélie Ter.
Thank you. So to follow up on Professor Wotering's suggestions, there is the public day happening at the IAC every year. So the biggest space congress. So the public is coming. And I always feel like all these years, there could be more interesting things for the public to attend. There is a discussion with astronauts, so usually that attracts a lot of the public. But there could also be a dedicated session there about communicating about space, and it's free to attend the public day. So maybe you can mark on that. I have another, more like a question. So during first of all, it was a great presentation. So I need to, again, repeat that. I'm very impressed with the work that you accomplished, the 3 products, the tool, the depth of the analysis for the roadmap, the awareness phases. It's really amazing. So that's really, I have to repeat it. One point that I would like to have an example for people who may not be the specialists. So you talk about champions. Who was working on that? The champions? That part with the... Right. Could you kind of give 3 top champion examples for us to get a more concrete idea of what you meant?
Yeah, so this was part of the segmentation of the general public, and we put it across 2 different x-axis, y-axis based on the sentiment towards space and the knowledge. And what you're referring to is the box 9, which is high knowledge and for space. So these are people who are in the industry, people who are, it could be the private companies, it could be academicians, it could be researchers. So these are all the people who believe in space and understand space and the impact it has on humanity. So these are the people who can really, drive growth and the communication down below. So our intent is just not everyone to just be for space, but to have high knowledge on the impact of space on humanity and then be for it. So that is the champions that we were looking at.
Yeah, follow up?
If I'm allowed more questions, then I will go on. This is a funny one. So from the whole team, who got inspired to kind of actually pursue this kind of communicating about space?
Who's the most inspired?
I also want to add, maybe we'll all talk.
So, I mean, I always love communication, but it was actually doing this project that I realized how much I like to not only be on stage communicating stuff, but actually learning about how to communicate something that might seem very complex, but if you do it properly, people might be interested in. And little by little, I think it's what it changed the world. It's not only the technology, but it's how you communicate it so the people support it. So yeah, I plan to dedicate my career to this from now on, but I'm not the only one here.
Plus one.
Yeah, no, similar sentiment to Michael. I think the biggest thing that I took from this, I think we all know how complicated it is to communicate space and even learn about space. But learning about the stakeholders and learning that the general public is the biggest stakeholder and they actually have more impact on the space industry than we actually anticipate. That was the biggest takeaway for me. And yeah, same as Michael, hopefully I can do something in my career about that. Thank you.
+1, I will also be just like them as well. My role more of it would be developing a strategy to apply the Earth observation applications, especially to the non-space actors, and communicating about their Earth observation role in climate action, disaster management, and a lot more stuff to the non-space actors.
I just want to say something that it's, with my experience, I work in communication and have experience with a lot of industries communicating, but one thing that was really surprise for me, that's the big gap that have the space industry. So it's something that we need to address if we could have more support for the world. So for me, it was really exciting to work in this and know that it's a real issue that we could attend, and it's important to start working on it. So for me, it was a pleasure to work in this project.
Good question.
Yeah, no, well, you're making me think about it now. I don't know. I think that it was definitely something I feel kind of like my mind was changed by this project. I came into it kind of wondering this question. I took the project on because I was kind of like, is space worth it? We do a lot of things that are like, sometimes it doesn't seem like it's worth it. There's a ton of, and so, but going through the project, I feel like I really kind of understand why people feel that way, why I feel that way. And we did a really good job kind of addressing those individual problems and then actually coming up with solutions for them. And those solutions made me feel so much better about really supporting it. Like, I love space, and I always have loved space, but I feel really good about pursuing it and supporting space travel now, deep space travel. Like, my personal mind was changed, which is cool.
Always valuable to have a resident skeptic in the group. And I have to say, the Morocco profile that you had, I've never seen a profile all in one spot. And whenever I saw that, that was very interesting. Just from my few glances at it, a lot of information was, spot on. And so I was impressed overall. So I guess my question from a technicality point of view, was that like a manual labor of love to actually make those types of profiles for every single country? And how will you keep it from not going stale?
Okay, so it was both manual and like actually using the technology that we had on hand, because this is like if you do it like manual country by country, it would be like a gargantuic effort that requires like years and years. But thankfully, there's pages and like organizations out there that already have collected this information, but they are like individual types of information. So to give you an example, the WHO or Reuters or, for example, ITU, all of them have interesting information about like some specific parts or some specific like sectors of the country, like internet connection, the demographics, like the percentage of young population. So we have like scraped all of this data, and then for specific like space sectors, UNOSA or like many of these organizations already have run in the past some reports about like how each country is like situated in space. We ran this, we saw what the gaps were, and from then on we moved to manual. So if we saw that UNOSA didn't have information about like Panama, then we went actually to see if Panama had like any space agency or like have they launched any satellite, even a student. So it was like a first, the technology gave us all the information that is out there, and from then we moved like to the manual effort so we can collect all the information. There's many gaps still and many information that maybe there are reports from 2023 that need to be updated. But of course, well, the information that is out there is what we have available, and it would be nice moving on to like actually partner maybe with an organization that has like all this worldwide support or like worldwide people like everywhere, so we could collect the information up to date. So this is something that we might look forward.
Okay, moving to our guest, global faculty professor here.
One of the oldest. I started my first SSP 25 years ago, but I love the methodology. What you have, the use of geo tools, analysis of country, but you didn't address the subject again. You didn't address the subject how to support sustainable human space exploration. So I remember when we had philosophy topics. If you do not address the topic, you get 0. The point what you did, you address more. So you developed a tool, and you have to put in perspective, like at ESA, we spent only 5% of our budget in deep space human exploration, 5% in robotic exploration, but you have developed a tool that you could use for each of the other topics. You mentioned, oh yes, Earth observation, I want to do something, application launches. So eventually it will be important to address the topic, deep space human exploration, so with the specific content that you have. You didn't talk about astronauts. Astronauts, that's how you capture also the attention of public because of astronauts. Even if you send only 5% of budget, then you create awareness on the other topics. So also using these dynamics, and maybe you're right, the topic is not so much to get more support for astronauts, it's to get more awareness for space in general. But we use astronaut as attention taker. And podcast, I'm not sure it's such an efficient tool. Why don't we have a YouTube channel? And you have so much material. You use your methodology, and every week you will have an episode about astronaut, Earth application, launches, and so on. So I'm ready to, to be a customer for some of this documentary. Also, a YouTube channels allows you to show action. Like in particular in space, you have so much of things you can show. We don't need to talk. You have images, you have stories. Astronauts, you have human stories. So maybe you should think of the next level, creating like a YouTube space channel. So who wants to volunteer for that?
Yes, and just to go back to that stat from Sia earlier, the 600 people club, that's a pretty strong club. But yes, maybe you can make some comments.
Oh, okay. Well, what I want... Do you want to answer first? Well, what I wanted to say, the only thing like about the tool is not, the tool is not the strategy. The tool is some information that you need to use in order to like leverage your strategy. So the tool will tell you which channels you have to use, in which way, and what you shouldn't do while communicating to that like specific country. So that's like what we call phase 1, to actually know who you are communicating to in order to not be or not like do any mistakes that make the people like distrust what you are saying. Then there's like the 2 next phases. Like the second one is like what we showed with the campaign, and the third one, in which we did something similar what you are mentioning. We created a podcast that was uploaded to the ISU YouTube channel. We were thinking of creating our own channel, but in this case we decided to use ISU's one because with the short amount of time that we had, it was better to actually have already that connection or that network of people that was going to listen to our podcast. So looking forward into the future, if we want to like actually use our strategy, the steps would be like, okay, yeah, we can create our own like YouTube channel for the organization that is using our strategy. They will use the tool to see who they are communicating to like check like the demographics, what's happening in that country, what is the space situation there, is there any astronaut that they can contact, is there any stakeholder that they can use, and then they will actually start producing the documentaries with all of this information. So yeah, we could, on your point that we should have addressed like more deep space exploration, which is like the main topic, is true, but talking about the tool now, the first step to actually talk about something is to know who you are talking to. So that's what we try to do. Do you want to say something?
And also to add on to that, to the specific question of not mentioning deep space exploration, we did so when we did the literature review. We begin from the beginning. But as the scope of the project got altered and the timeline kept adding on, we realized that we were developing a project for people who are already aware, like the space professionals who are already aware of deep space exploration. Hence, we took the focus less away from deep space exploration definition itself and focused more on how we could leverage the product or the tool that we have created to empower them to communicate to our general audience. So that was the flow we followed, and hence less focus on deep space exploration itself.
Well, actually, I want to talk about the tool. One part of education is talk about these kind of topics. So we need to address these kind of topics about the space exploration, about astronauts, about missions for each country. So this tool is useful for the first phase, is to approach to the general public, but then in the education, you need to talk about these topics, about the space exploration, and in the tool we have the steps that you could follow to address that kind of topics, and you could have more experts, you could have interviews, but this is the roadmap for the epistemological change of mind for 10 years. So it's not just one campaign. So we need to make this change, and one of the topics on the space exploration is the part of the education. So we could talk more about that. That is part of the strategy inside the tool.
Great. And the podcast team? Yes.
Yeah, thank you for that information. So just to add on the podcast choice, as part of the assignment that we've been instructed here as part of the TP was to choose a product where we could demonstrate our strategy. So we chose the podcast because it was, for us, Michael mentioned that we wanted to create our own channel, but it was a bit difficult to find new followers and our audience. So starting to build the audience through the ISU channel by producing a video podcast was the best way. I think we guys all agree on that we love the podcast, actually. Personally, I really appreciate it because we had a lot of propositions, and the podcast was the obvious one for this specific topic. And yeah, maybe in the future we could eventually, after building this audience, after initiate this idea of space need to be communicated differently, after addressing all the gaps and the challenges we may have and how we can address it to sustain our activities, maybe later we could definitely have create our own podcast or our own channel on YouTube or another platform. Even on Twitch, we can do live stream as well, talking about space, why not? But yeah, for this specific project at ISU, we chose the podcast.
Yeah, and it's very interesting how today the media consumption is either 15-second swipe or 1 hour podcast. As people are so like, either one short or super long format. So it's kind of nice that you guys actually, with the YouTube shorts that you had, those came on my feed, honestly, too. So it's like, I was getting engaged at the 15-second and the 1 hour. But I'm going to pass now to Professor Goldman.
Thanks, Anwar. So thanks for a very nice presentation again. That was very informative, and I think you described pretty well what you've done and the different products that you created. I think I've heard someone say it's difficult to learn about space, so I'm not sure if that's the conclusion of your school here. Or maybe I misheard, I don't know. I think I heard you say that. I just have a couple of questions. So, also another comment is a nice mapping of the 7 ISU disciplines into your project. I think you did that very well. So, in my understanding, the 3 phases are consecutive. So, do you see actors that are willing to wait so long to get to the 3rd phase? Presumably, they all think they are way beyond where they should be. So, do you think that they actually they would be willing to do the 1st phase and then 2nd phase before they reach the 3rd phase?
Well, these 3 phases, first, the awareness is to approach the governments, the space agencies, and the actors who are involved in the space. So we could give some guidelines in communication strategies so they could adopt our tool. So this is the first phase. So we have 1 year approx, or 2 because it's around the world. So we need to first convince to the space agency and governments and institutions who has this aware of the space, so they could communicate to the public. So we have this first phase of awareness, and then we continue educating. So it's something that is like in the same time. For example, if we have the awareness of the space agency for France and the government, so they could start making the first campaigns. So they could put the campaigns because each country works different. So they could address that media, they could get our professionals in some expos, in something, they could start. So we could make phase 1 and phase 2. So they could start educating. And then we could have the public support for France. So we could make this for each country. So it depends on the space industry, in the governments, in the institutions. So we could develop this. So it's phase by phase, and the actors that we could involve. So that's the way that we could approach around the world. So that's the idea.
To add to it specifically, as you mentioned, it's consecutive and also depends on nation's capacity. For example, if you're already developed, you do not necessarily need to do the awareness if the public is already aware. So they can already go to the strategies that they really want to implement, maybe phase 3, where they start, where they want to start including mission plan and educating people on how the end of life is going to be, or involve people in all the stages of the mission. So it depends on nation's capacity and what tailored audience they're trying to engage with.
Great, and I found it very interesting, the finding of the tier 1. Yes, I'm coming back to you. The tier 1 with the tier 3 on India's case, which was very interesting, where there was capacities to do things like even launch, but then because of certain factors, it's like, so it's kind of straddles 2 tiers. It makes it very diverse, the way that you have to approach each individual case. But back to Professor Goldman.
Thanks, Anwar. So yeah, one question about inclusivity. So of course I value, how you approach things. Of course that matters very much. And I was wondering, would you say that the actors you talk to, they should be able to pick and choose their priorities, depending on countries or agencies? What do you think about that? It's a bit of a trick question. So, I mean, you propose a number of actions and priorities that the actors that you're going to approach can view. The question is that, in your opinion, can they pick and choose what's important for them, for the country, for the public? That would be yes. It's just yes?
It's yes, because, for example, a nation like... No, so
for example, tier 1 nation of North America can still have priority of the underrepresented communities. So they could, based on the recent event in Hawaii, so even a tier 1 nation could have.
So, yeah, what about if, you take NASA, for instance, so they just scrapped out of the priority inclusivity. So how would you handle this? That maybe different actors you want to interact with actually might not align with your priorities.
But in any nation, if a nation has to continue spending in space, the whole nation has to move forward. So even if NASA scraps, inclusivity as a priority, I think companies like SpaceX will probably do that.
And also in the current space treaties, we are believe that all the countries are standing together. Like we share the same goals, all around the world. Even some of the countries are leading, and they have the strong perspective, to leading the space topics. But we think the whole human beings are having the same goals on the development of the space, and it's also the goodwill for the space treaty, what we are trying to do, to spread the space ideas to every country. So I think this is also part of our goals in to make people participate and to have the same idea.
Hi, so if I could add a little bit more about prioritization of the inclusion. So first of all, a big disclaimer, you cannot reach every single people group. It's not possible to do that, especially just right away. So yes, you definitely do have to prioritize. And one way that you can prioritize that is finding resources that already exist. So for example, one of the things that we were looking at was an organization called Astro Access. So we talked with several different stakeholders who already are advocating for accessibility and inclusion and diversity within the space sector. And so so Astro Access is one of the organizations that do advocate for people with disabilities and how to further engage them within the space sector. So maybe one of the ways that they could prioritize is like finding those kinds of organizations and maybe also partnering with local experts. Like, for example, we talked with several different experts who had various backgrounds, who had talked about academically some perspectives on indigenous and traditional peoples. We also talked with somebody who was from the disability sector and was is a strong advocate for that. And so learning from their experiences for sure is just very important. I think that we also learned how to further engage them because of their lived experiences. For example, one of the things that they were mentioning was having an accessibility statement, which we put into our reports. We also made sure that our visuals and our formats were more accessible in terms of being. We took into account color blindness for our visuals, and Grazia can definitely tell you all about the research that she did there. There was also epilepsy, trigger warning, or keeping that in mind. And so there was definitely a lot of different aspects in terms of what we researched and in terms of what you could prioritize.
What a great note to end on for the possible future I for ISU, inclusivity, huh? So a little plug for that, who knows? And so I want to thank everyone again for coming and joining us at this for these amazing TP projects this year. Again, this year was different than past years in that we had actual products that, besides the report, things you can use. So please read the description, or maybe click here. I don't know. I'm pretending. I don't know. But on YouTube, we'll have our links to for you to explore more of these tools. And if you have feedback for individual projects, you can reach out to them to let them know how the tools worked out. Anyways, thank you all. Thank you, Professor Virginia. I see you popping in on here again. Thank you very much. And if we can give a round of applause for them and everyone. Great, and let's get some pictures, huh? We got to get some photos of the group. Aurelie, please come down. Oh, Professor Walters, they would like you to come down as a co-PI on the grant that they funded. Of course, you have to come. Okay, good. Yes. And, oh, where did Virginia go? Maybe we can get Virginia on the screen as well. Perfect. Okay, roadmap on 3. 1, 2, 3.
Nicola's back. Let's take another one.
Oh yes, we got Nikki here too. Hey, Nikki. Oh. Yes. Yes. Thank you again. Thank you, everyone. Enjoy, and see you next year, hopefully.